All right, welcome everybody. It's the 23rd of November in Dallas. This is Dallas Personal Robotics Group Robot Builders Night Virtual. We will do the normal thing in a moment or two and just go around the table and talk about projects we're working on or questions and issues that we have. Just a little bit of housekeeping before we get started. There is a chat server on Discord that's getting a growing number of people, thanks to one of our frequent member participants from New Zealand. There's a growing crowd, lots of discussions, some group projects. If you're interested, just throw a line in the chat for this meeting and we'll get you a fresh invite. Coming up in December's monthly meeting, Paul will talk about his recent gig working on self-driving trucks. And then just looking forward, on the 8th of January is the time for our regular annual meeting. Since we are formally a 501c3 organization, we actually need to hold elections. That's on the agenda for that month, as well. A year in review by outgoing president, yours truly, Carl. And then the rest of the meeting will be incoming president, Mr. or Mrs. TBD. So we probably need to start talking about that relatively soon so that we can actually figure out who wants to start running for office. And then Jack, I've been meeting with him. He's got a cool presentation on his journey since he started with DPRG like 5 or 6 years ago and as a younger youth in school. And he's going to talk about his journey, but that won't be ready till after the January meeting.
Carl, you might want to state a couple other things. If you're a member of DPRG, and a lot of the people on here are, then you feel like you would like to be considered for office, to shoot Carl a little quick email saying what position you're interested in, and we'll get you on the ballot. Okay, so something to consider.
And that would be greatly appreciated.
Yeah.
Because it's all volunteer, and you've seen a lot of the same names over and over again. And we actually do have term limits, so I will not be running as president again, unless somebody pulls a fast one and changes the bylaws. But there's president, vice president, secretary, treasurer, librarian, webmaster, postmaster. And as you can see, Doug's got some pretty big shoes to fill. And then there's 4 others of us too. So,
yeah. So, I'm pretty, with the postmaster and the webmaster, I'm pretty full up. Luckily, the secretary job is not real hard. You pretty much have to document the annual meeting. Other than that, so that position would be open if you wanted it to, if you're interested in that. Okay. If not, I'll probably do that again.
So you can tell these elections are pretty casual. We often have one candidate for any given seat.
Yeah.
So keep
it
in mind.
Yeah, consider it. If you
Clay expressed interest in being president or no?
I think we're probably best to rule Clay out. I think he's been pretty buried by stuff. I haven't been able to catch up with him all that much lately. So,
okay.
I think we ought to look within the regular people on this call, for example, right? However it goes, we get a lot of help from people who aren't even formally as the title officers. So don't think that it's all on your shoulders if you want to run for one of these spots. So anyhow, that's coming up soon. And I would guess, Doug, that by the December meeting, which is only a few weeks away, we should probably be announcing the proposed slate
Yeah, probably that or a week after.
or week after, and candidates. And we should also round up our PricewaterhouseCoopers arrangement, otherwise known as Ron Grant, who typically tallies the votes.
Yeah. Okay.
Okay. Well, that's the kickoff. So tonight we have a growing quorum on here. Welcome everybody. If we haven't said welcome already, just as a reminder, we record these for later. So if you'd rather not be recorded, then just mute your camera and your microphone. With that, we have in queue Pat, and after him John G, and Kumar with some lighter questions, and after that a free-for-all. So Pat, if you could lead us off, that would be great.
Okay. Hey, everybody. So last week I had mentioned I had a problem with, I'll start off with, I had a problem with Platform IO and Git bringing over my my libraries. So when I uploaded to Git and pulled everything back down, I wasn't getting libraries with Platform IO my projects. With the help of a few members and Chris Netter, I was able to get that working, but it still gave me a problem once in a while, and I couldn't figure it out. And I'll present my screen, and I'll show you what I found. So basically, right at the bottom of my screen, and I don't know if you can see that, switch platform project environment.
Ooh.
And I had to go from my one project to my other project in the same folder. And once I did that, it rebuilt all of the libraries inside of Platform IO. And that's happening, I believe, because I have this as a workspace in VS Code.
Mm-hmm. Otherwise, you're saying, Pat, if you had one project per one project per project, I guess, instead of using it as a workspace, that everything would have been kosher.
I think everything would have come back, like it would have rebuilt the libraries right away in the code.
Well, that's a hypothesis, right? You don't know for sure. I can try that. I just tried another experiment, and you probably haven't seen that email yet, but I don't use Workspace. I just do open folder, and I'm not seeing that issue, and I deliberately deleted the PIO folder, right?
Yeah.
And then I just went in, said file, open folder, and it does take a while. My laptop's not the latest and greatest, so it does take a while for VS Code to load extensions, and in particular to load the Platform IO extension. So it's busy doing things. I can tell, all the icons on the bottom haven't really fully populated yet. But once it settles down, I could tell in Explorer, okay, the folder's already been recreated and repopulated. So I was expecting I'd have to at least kick off a build or something, but I didn't even have to do that. It just, as soon as it finished, loading everything it needed to load, it had already recreated the PIO folder on my end. But again, I'm not using the workspace feature, so maybe that makes a difference. I can do a quick experiment while others are talking and see if that makes a difference for me, and I'll let you know.
Okay, so I may end up deleting my workspace file and just leave it as separate folders.
What version are you running? Okay, same here. All right, same here.
So that, and then Platform IO. Platform IO, I believe, is the latest. 5.2.3 and 3.4.0.
Yeah, I got the same. Yeah, so Hmm.
So I think it's just a problem with the workspace. Since I created the workspace folder, I think that's what's giving me issues with it.
Quite possible. I'll let you
So-
know if I see the same. And okay? So you're doing this on Linux. I'm not sure that makes a difference. Right now I'm on my Windows, so I don't know if there's a difference between the two. But I'll let you know what I find with this with the workspace.
Okay, and then the other one I had is Wooden Monster. So my robot, the Wooden Monster, finally got it rolling on the weekend, and with the remote control. So I don't have any video to present. But
Can you show the robot? Pat would like to see it if you got it.
Okay, give me a second. I'll just go get it.
Okay.
Okay, give me another second because I got to power it down. It's plugged into shore power.
I thought you might have it wandering around your backyard there.
No, it's about to get too much snow in the backyard. Okay,
Shore
I'll go
power,
get
is it the size of an RV or what?
No, it's pretty
A
big.
boat?
Put a blade on it and make it a snowplow.
What?
He said put a blade on it and make it a snowplow.
Ah,
There's a competition, one of the northern states for autonomous snowplows. I think it's a college competition.
Yeah.
I think we had Pat talking about it before. At
Ooh.
which point Kareem brought up a photo of his skateboard-based robot. Pat, Wooden Monster.
Wooden Monster. Yeah, let me shut down this screen so I can see what everybody else is seeing. And basically, that's it. So it weighs about.
Wait a minute. Hold it there. Okay. Wow. Those look like the pneumatic tires. Can
Yeah.
you show? Can you show the bottom how you got? It looks like you've got some sort of drive.
Yeah.
Is it a belt drive?
So it's belt drives,
Okay.
dual belt drives with a cog belt,
Okay.
couple 37D Polulu motors
Yeah.
with encoders. Great big sealed lead acid battery.
Yeah.
I got the
what's the
three
diameter of your wheels?
ultrasonic sensors at the front.
Yeah. What's the heat sink behind above the?
Oh, just above the. That's a 5-volt regulator.
Okay.
So it's a 10 amp 5-volt regulator. Got Raspberry Pi on top.
Yeah.
And I don't know if you can see that. There's the motor driver I've been working on.
Okay.
Now, the one thing that stands out to me is, that plywood is too thin. You should have gone with like something much heavier duty.
Pat, it looks great.
I thought he was making him a robotic welder. That the battery and stuff. That's what I was thinking.
No, it's just something that's hopefully going to have about 12 hours of runtime. Just cruise around the house.
Pat, it looks great. Great work.
Yeah.
Thanks.
Yeah.
Look,
What's the diameter of the wheels?
Those are 6-inch originally pneumatic tires,
Huh?
and I foam filled them. So
With spray foam, or
no, I
like-
used the big 2 foot by 2 foot play mats you can buy in the store, the foam ones
yeah. Okay.
for kids, all multicolored.
Yeah.
Well, I cut them into a bunch of strips, and I laid them inside the tire and built it up
Okay.
with foam filled. So the problem I had with the tires is that the tubes would leak right around the valve stem,
Yeah.
and I just couldn't get them to stop leaking. You'd have one, it would work good, and a few days later, it's starting to leak again. So I finally said, okay, I'm going to foam fill the wheels, and I'll be done with it.
Did you try? They have this. I've never used it. They have this stuff that you put in your car tire, right? That closes up any leaks. Something.
Yeah,
Slime.
It seems to be the way that the rubber is fitted to the valve stem. So it's leaking right around the gap between the rubber and the valve stem is leaking.
Are these from Northern or Harbor Freight or?
These are from Princess Auto in Canada.
Okay.
So I found them on Amazon as well.
Okay.
Are the wheels keyed?
The wheels, I had a local machine shop manufacture some hubs.
Oh.
And I had them make them with originally with a 1/2-inch key. And when I switched motors, because I used to use some Bainbots gearboxes, they were really loud. And I switched to the belt drives, and I used an 8mm shaft. So I have an 8mm to 1/2-inch collet adapter, and it's actually for a router.
Oh, okay.
It's to adapt your router bit. So if you have a 1/2-inch router, it'll adapt it down to an 8mm shaft. And they're very, very hard, and they seem to be working good so far.
Okay, and I assume that in the middle there's some sort of support bearing. So
yeah, there is.
I can't quite understand that. You know,
they look like pillow blocks.
Looks like he has ball bearings at both ends of each shaft.
Yeah.
So there is.
So there's a gap after between the two shafts. Obviously, they have to be independent.
Yeah. So there is about a 32nd of an inch gap between the two shivs on the end.
I got you.
And then there's 4 pillow block bearings.
Gotcha. Okay, cool.
I like the red switch on top. If I'm reading it right, I don't know what it does, but I like the red switch.
So who is the electrical engineer out of the group? What I need to know is if I use, so when I'm running on shore power, so right now I'm just using a Raspberry Pi adapter, and I'll plug it into 110 volts and power up the Pi. But I'd like to have a way that I could have it run off of the battery. So if I leave the battery switch on and I plug in a shore power, that I can use like 2 diodes.
When you're saying shore power, I'm not sure exactly what is it. What's the shore power?
Like shore power, so I can plug it in or unplug it without shutting down the Raspberry Pi.
Oh, okay.
It's a cruise ship. This wouldn't.
So it's the mains, basically.
Yeah, the mains.
Yeah.
So I'm looking to do. Can I use a DC adapter and slightly higher voltage than my battery? So I got a 12-volt battery. So if I had a 15-volt adapter, and the battery and the adapter both going through a separate diode, and combine that to the input on my voltage regulator.
Okay.
I mean, if you look inside the Arduinos, that's, I think, how a lot of them do it in the schematic itself, right?
Yeah.
The fact that you're using a lead acid battery makes charging a lot simpler than most of us are having to deal with, lipo batteries, and that's much more complicated because you have 2 ranges, but essentially once you get up to 4.21 volts, you can't go above that. You'll mess up the battery, and so the charger can never go up above that.
The only suggestion I have, is pull-a-loose stuff. All the pull-a-loo things that I'm used to, they're always very good at managing that sort of thing, right? Or like you can power it through USB, but if power comes in from here, that's fine too, and power comes in this other way, that's fine too. I'm not a double E, so I don't know how they do it, but like it was just suggested, if you look at some of the schematics out there of some of these things, the solution is there, and pull-a-loo seems to really get that power distribution. They seem to get that very much, right in their boards.
Mm-hmm.
Yeah, I've seen it done with like I say, two diodes. So on each of the positive sources, you have a diode, and let's say feeding into the voltage regulator. So you'd have one from the battery to the voltage regulator through a diode, and then one on an AC power adapter through a diode to the same input on the voltage regulator. And the idea is that the higher the voltages would conduct. So my question becomes, if I use a regular diode, so let's say I put a 10 amp diode on it, is it enough will it switch over quick enough between one power and the other?
Generally
Or
speaking,
any-
this, the switching is pretty quick.
Or would I need to use like a Schottky diode?
Now, Schottky
Schottky,
diode
yeah.
usually what that buys you is a low forward voltage. Okay,
Less
so
power
it
dissipation.
turns on faster. Probably
0.7 volts would not be forward voltage drop on a diode wouldn't be a problem as far as
because
voltage to the regulator.
Yeah. So the main thing I would imagine is that you just want to make sure that it's got enough current capability.
And
Yeah,
heat
it's something like
dissipation
10 amps
because
would be 7 watts.
Yeah.
yeah,
Are you doing charging, or you're just trying to run your Pi, from mains versus from battery?
Just for mains versus battery. So the idea
Yeah.
is that the charge.
Wait a minute. Wait. Whoa. I missed something. So you're trying to run your Pi.
I'm trying to keep the Raspberry Pi running from essentially an AC mains or an adapter
Without draining the battery.
instead of the battery. So I'd be able to take the robot, pick it up, put it on a stand, plug in the power adapter, and turn off the battery with the big red switch.
Yeah, I see. I mean, I do something similar actually, except I go kind of either way one step further. What I end up doing is, I guess I end up just charging every time I'm stationary back, right next to me down here. I plug a makeshift charger right into the battery terminals, and it's not really a official charger. It's just something that does current limiting, right? And I set it to a voltage that's in safe territory for my I have six nickel metal hydride cells in my platform. And so I just set it to the right voltage, set it to a current limit. So that way, when I'm stationary, I'm not continuing to drain the batteries. In fact, it's more like the opposite. I'm even slightly charging the batteries, and, I'm basically running, the Pi and the sensors from my, from AC that way.
Eventually I'd like to do both, is to plug it in and then I can keep the Pi running and charge the batteries.
Yeah. But I've also done what you're describing, again, because the Pololu always, they say they don't care whichever you plug in. I have previously, before I started doing the charging setup, what I had going was I went straight with the USB-C cable, into my Pi 4, right? And so I was powering my Pi 4 from the wall, and and I would actually turn the battery off because I can do on my Pololu setup. I can do that. I turn the battery off, but power the Pi that way. And again, because the Pololu boards all take care of that. I don't know how they do it. I'm sure diodes involved and maybe some other stuff involved, but luckily they just take care of that, and I don't have to worry about the details. And so I'm saying, if you look at those schematics, you might find some ideas there how to do it efficiently. But the diode setup seems like it should work, right?
Ideally the higher voltage diode should be conducting, and the lower voltage one should be blocking, and allow the 5-volt regulator to stay powered up.
Yeah, I guess I'm missing what, Pat, how I would probably, because like Chris was mentioning with his Raspberry Pi, he was with Arduinos too. You can plug into your Arduino while your battery's turned off, and it will feed your Arduino, and anything that's hooked up to it, its 5-volt supply will get on. But for example, your motors aren't going to turn. But your processor is going to be powered up because you need to do that to just program it.
Yeah.
Okay. So that I don't. I just have a switch on mine and turn it off, but I don't know if I don't have a built-in battery charger to charge my batteries. One of the things, though, that one scheme might be, okay, you don't worry about, you just charge the battery, and then the battery feeds the the step down voltage uh, voltage converter, and then that feeds your Raspberry Pi. So you don't have to worry about charging just the Raspberry Pi unless you want to isolate it to just run it by itself. Is that
Yeah,
what you want to?
that would be the idea. Is half the time that I don't, if it's sitting on a stand, I don't need to have the wheels going.
Yeah, gotcha.
So
For test code, you mean? No, go ahead, David.
Pat, I essentially do it the same way Doug was just describing. I think that's what Chris was describing also on my big robot, which is that there's just a parallel set of cables attached to the battery terminals that goes up to a little connector, and they're directly connected, so the on-off switch is irrelevant. And then on the other side of that, on the other side of the batteries, is the the regulators. I have a couple on that one. So that they're always driven by the battery, and then the battery can be, in addition to that, can be being charged. And you can, turn the robot on or off. But, so basically, anytime I plug the robot in, it's charging.
okay.
So Pat, there's another idea. There are little UPS things that you can find specifically for Raspberry Pis.
Mm-hmm.
And I think Murray has some experience with one that he's used, if I remember right. These are 3 that I just found with an Amazon search.
Yeah, I've seen them before as well, with a little LiPo battery that'll charge up and can carry on.
So that might be handy as well, because then if all you're looking for is code development and you don't need the motors and things to run, you can just have that run, and then let the main power switch drive the motors and stuff. I like David's idea and what Doug are talking about, where just run everything off the battery, and especially with lead acid, just your system's powered off of the battery, so the battery doesn't care if it's draining itself or being charged at the moment. So just hook the battery up to the shore power, and
the battery does, the circuit doesn't care then if the shore power is probably giving you 13.8 volts or something like that to charge the 12-volt battery.
Yeah.
And but it doesn't matter, because your voltage regulators are on the other side. So whether you're regulating 12.6 or 13.8 down to 5 or whatever.
One thing that you would want to be careful about is that some boards, give a max spec of 12 volts. I'm just saying. So you could get in a situation where if you were charging it with 13.8, you might blow the regulator. I'm just saying, take a look at your board's regulator. I don't know what it is on the Raspberry Pi. It might be 25 volts for all I know, but you know what I'm saying? There is going to be, on their regulator, there's going to be some upper voltage that you can't
max
see.
input voltage. Oh, Chris has something. What do you have, Chris?
So this is what I'm using to charge. Again, it's not a charger. And I don't have any fancy benchtop, power supplies where I can vary the voltage and do current limiting. I've always wanted one. Don't have much, so this is one of those dirt cheap things that's surprisingly useful. I don't know, maybe $10, $15. It takes, I don't know how much voltage it takes in. I'm feeding it from a 20 volt old laptop power supply. It's a step down switching regulator where I can set the voltage, and I can set the current limit. Yeah, it doesn't have any knobs. You gotta, it's got this multi-turn precision potentiometer, so it's not terribly user friendly, but it works really well. I set the output voltage to like 8.55 volts for my 6 nickel metal hydride cells, and that's I found that to be just at the right level. And I set a current limit, usually at around, let's say 700 milliamps or so, and I can just have it plugged in. I know it's not going to overcharge. I might not end up fully charging it, right? I'm not aggressively charging here and then trying to cut off right at the sweet spots, I'm probably only charging to 90%, and I don't care, right? But this is convenient, right? I plug it in, it's charging, and it's powering the Pi. It's and I don't have to really think about it much, and just leave it plugged in. So it's one of those cheap gadgets, right? Like this component tester thing, right? It's like one of these things that's $10-15, but surprisingly useful. And
Yeah.
it packs quite a punch. I mean, I don't remember the specs, but I think this will put out 5 amps. It packs a punch. Yeah.
With the heat sink, you can do 5 amps and it's switched, so it's very efficient, no matter what the input voltage is.
Yeah. So
I use the same one, I think, and I just put a link. I've used it multiple times. I put a link for it in the chat.
Yeah, I got a couple of those on my bespoke thing that I'm doing too. I set 1 to 12 volts and 1 to 5 volts because the motors want 12, or they really like 12 anyways, and the Pi wants 5, and I seem to be pretty. They seem to be pretty rock steady. I don't think they were much. I don't think they're expensive. They're like what, $10 a piece or something like that. Something like that. Yep. Not very expensive at all.
They have fancier ones. They're fancier ones with knobs that you can actually turn with your fingers, right, instead of a screwdriver. But this one was a good deal, and it does the job.
I'm in Canada, so you're saying $10, but it's $10 plus $30 delivery.
It's like a DC offset.
I've got one other thing to present, guys, on a weekly robotics newsletter that I get.
Which you're going to put in the chat.
I'm going to paste it in the chat.
Yeah.
And I'll just show you guys website again. And basically, this is the site, weeklyrobotics.com. And basically, this is what I receive every week. So it's just a bunch of articles and what the latest news that this guy picks up for robotics everywhere. So it talks about robots used for harvesting, self-driving cars. There was an Indy race a couple of weeks ago.
Yeah.
There's the one I posted in the news group today. Thought it might have been of interest to people. So all sorts of different stuff. It comes out every Monday.
I did ask a question. I mean, I know the SICK LiDARs go back and forth like that, but has anybody seen any hobby LiDARs that do go back and forth over on only in front of you, for example?
No, unless you build it yourself.
Yeah, I've seen some of those, but I mean, I was just wondering if anybody had seen one that just went back and forth.
No, all the cheap ones spin around in the circle. When I first saw your article, your in the mailing list, Pat, it caught my eye actually, because this whole notion of distortion of the LiDAR data is very dear to me, because I run into that with the cheaper LiDARs, and so I'm gonna have to take a closer look at it. But I got the sense that talking more about moving objects and that sort of messing up your LiDAR scans. So that's not, I don't know if I read it correctly, but if that's what it is, then it's not the same problem that I run into. But I run into the problem of the LiDAR moving, right? And that's distorting the data you're collecting.
So that's what I thought they were talking about. So as your robot is moving, distorting essentially the map that it's creating.
Yeah. If that's what they're talking about, then I'll have to read it in detail, because that's exactly the problem I have, and I've come up with an algorithm to tackle that. It's working so-so, and it's just something that I'm interested in potentially solving. It's just a little side project.
What's Ray holding up?
Yeah, this is the what's on Omega, and they actually sense the input voltage with a comparator, and if the input voltage is there, it gets turns this FET off and gets the voltage from, let's see if
it's the 5 volts there.
Right.
USB.
Yeah, 5 volts. right there comes from the linear regulator on the board.
Yeah.
But if there is, if that's not there, it allows USB power to pass through the FET's on at that point. So that's how they switch the DC. But I think having a charger that has enough capacity to charge your battery and run your unit is a much easier scheme. You don't have to,
12-volt battery chargers are, a couple amp charger is pretty cheap.
Yeah, they're pretty common.
And that would be probably in the scheme of things, if this thing is left to operate on its own, at some point it has to find a charger and contact a couple plates and charge itself.
Yeah.
Mm-hmm.
But that's how they do it on the Unos and the Megas. And
so I do have one other thing I wanted to bring up. Besides, Murray's not here, so the one I was thinking about bringing up was all the tuning I've been doing on my PID loops for my 3D printer and all the servo and ballistic routines that go with it.
Yeah.
But since he's not here, I'll wait till next time.
Nice.
So, the other one I do have for you guys is I really enjoy these meetings. They're good to have. I'm remote. There's a bunch of us that are remote that is nowhere near, even in the country really, that we can go to for a group to, to talk and discuss things robotics. I know your elections are coming up, and I've, looking at the website, I've often thought of becoming a DPRG member. It's just, my proposal to you guys is to create an associate membership for people that are remote, that'll never take advantage of some of the facilities you guys have and the costs that go with that, but still be able to partake in the group and donate. So my suggestion would be to half cost or 60% of the cost to be able to be an associate member.
I think that's a great idea.
Yeah. We'd have to work out the details to make it for everybody, everybody in agreement. But, I'm not too opposed to something like that.
I'm not asking anyone to make a decision on this. This is, this is just my idea. And I know there's a few of us on the list, and I can't speak for everybody, but I know that I really appreciate this. I've been watching, originally started watching the videos from when COVID started, and then eventually decided to not be a lurker on YouTube and join.
Yeah.
And I really enjoy it. It's just $50 US, I believe is what the costs are annually.
No, 40
US.
Yeah.
It is, let's say, about $52, $53, let's say, Canadian.
We've never had to face this before the pandemic because we weren't online. Everybody by definition was gathered in the same building.
So this may add incentive as well to say, okay, you guys are going to go back to regular meetings indoors at some point, but maybe
I hope not.
Well, I personally enjoy these too, Pat.
Or something,
I'd love to see them keep going too. I think the best way to do it is just make the, again, this is going to be something, if you're in the elections and in whoever's going to take over next year, but I would love to see this become a permanent thing for us. And it could actually reduce our cost a bit if we could, right now we use the Dallas Makerspace, and that costs us a very reasonable amount, but it is by far our biggest expense. And what we get out of it is a meeting room and storage. Now, the meeting room could probably be swung without this deal, because people in the club are members of Dallas Makerspace, so they could basically schedule a meeting. It probably might cause some hard feelings, but the storage, we'd have to find a new place. And I don't know, in the end, to be quite honest, I'm not sure if the storage is much cheaper than what we got right now, because we do get a good deal with Dallas Makerspace. I mean, if you tried to find a meeting place and a storage place for what they charge us, it would be it'd be hard to find.
Well, I'd just
So-
like to stick in there, Doug. You know, basically, we've always bifurcated this into monthly meetings that were things that we held at the makerspace, and then the Tuesday night RBNOs, which have drifted around to different locations, although
Yeah.
lately they've been at the makerspace.
Yeah, because we
So-
had room.
Yeah, exactly. I would just say from my own perspective that the in-person Tuesday night RBNOs were never as organized and productive as what we do now on Tuesday nights. You know,
Yeah,
it'd be,
I
two
agree.
or three people sitting over here talking about something, and but I just find this a whole lot more valuable.
Oh, I think what you run into before was the motivation, I think, for the Robot Builders Night Out was different than the virtual. The virtual is basically, like you said, it's kind of here you talking to everybody at the same time. And when you're discussing robots, the Robot Builders Night Out was more set aside some robot time every week to go work on robots. Okay. And that's a different purpose than what we're doing here. And, you know, I'm not sure, for me, it was an expense because I live on the other side of Dallas. So for me to drive to the makerspace and come back, now this is going to blow Pat's mind, you know, I basically had to use because I was driving a Jeep, probably about 2 to 3 gallons of gas. Okay. And I was having to go on a tow road, which was costing me probably about $6 to $8 per week.
Each way.
Per week.
Yeah.
So it was $6 to $8 plus 3 gallons of gas, plus the member, you know, to go to the meeting. That's a lot of.
So
lot of
you're
money.
telling me with the 3 gallons of gas, you need to take out a loan now to get to the meeting? Is that what I'm hearing?
Well, no, now
Yeah.
I got a car that actually gets a decent gas mileage, so it's not as bad. But
Because it
still,
sits in the
it's
driveway.
still expensive. You know, it's more expensive for me to go to Robot Builders Night Out than it is for me to pay for the Dallas Makerspace.
Time to go electric.
Yeah.
This has a
Well,
much less,
that would
carbon
help the
impact.
toes.
How much is a gallon of
Totally.
gas?
It's around, I don't want to say
$3.
about $3.
Yeah.
And
Yeah,
we're
the
in
national-
Texas,
the
so it's
national
a little
average-
better.
National average is about $3.40 or something.
Yeah.
So a U.S. gallon is $5.50 here.
Yeah, so it costs you
So you live in
somewhere,
California?
it costs you somewhere around 3 to 4 times in gasoline than it does to charge an EV now.
Plus,
Yeah.
that trip to the makerspace would be real expensive for Pat.
Yeah.
Yeah.
Yeah. He would have a,
Hurry.
It would take a that's a day and a half solid driving commute there and then a day and a half back. It doesn't leave much time to build robots.
But we
Yeah,
get to a
so-
cup of coffee for sure.
yeah.
Think of Murray, you know? I mean,
Yeah.
God.
Plus, this has opened us up to so
Murray's
many
got
new
less of
people.
a commute because he's leaving already. He's leaving, I guess, more of a commute because he's leaving tomorrow.
Yeah. He's leaving. He's leaving in the future, right?
Yeah, do that.
So he's got a 13-hour head start.
But I would just reiterate and agree with Doug that these serve a different purpose, and I find them much more organized. And as he said, each person gets a turn to have everybody's attention. And so there's much more of a group mindset involved. The Makerspace Tuesday night events, they've started, I think it was in Barry Jordan's garage, which he had, all these machine tools and workbenches, and we went there to build. And especially for people who didn't have tools, that was a big deal. So I don't know exactly how all that plays out.
Yeah, and we pretty much lost all of the tool rights in the Dallas Makerspace except for our members who are double members, And so the Dallas Makerspace is really nice, guys. It's got every tool that you would want. It's got that tool, but it's got it on steroids. So like if you're wood cutting, you have a table saw, I'm sure, Pat.
Yep.
They got a table saw.
It's
cabinet
cabinet grade.
You know, I mean, plus their woodworking shops got every possible tool. You can make furniture in there without any problem.
Yeah, that
Yeah.
that CNC cutter they got that'll take a full 4x8 sheet of plywood.
It'll
Pretty
actually
nice,
take,
man.
yeah, bigger than that, I think. I think it's
5x10, 17
Yeah.
horsepower blower to hold the piece of wood down so that a 4 horsepower router can do 3D routing on it. Make yourself a guitar bass or whatever you want. So
they got plasma cutters. They've got full welding shop. They got a what do you call it? Traditional machine shop. Lathe, Bridgeport.
Lathes,
It's been a while, but the last time I went through there, they've got a couple of lifts too, and a couple of yakkos that had their cars in there doing the modding and stuff on the thing. I mean, full auto lifts and the whole.
4 lifts for the auto lift.
Yeah.
Laser cutters with like 4x6 beds or something like that. 4x5 bed.
I mean, so it's a great place. You know what I mean? It just happens to be on the other side of town.
Well,
If
for
you-
those
if
who,
you can convince people like me to donate to buy a subscription to DPRG, then that lets you afford maker space easier. So now you've got your storage there with less hassle.
Yeah. So
those
I
who
think
don't know the history, the DPRG had moved from site to site. We'd get a site and stay there for 3 or 4 years. And basically we started the makerspace.
Yeah.
But then it sort
There's
of
actually, if you go on the website, you can actually see the history of the foundation of Dallas Makerspace on the DPRG website.
so
I think I've
that was
seen
our
that.
idea to getting ourselves a space, but eventually we got kind of squeezed out of that.
Yeah,
We're
too
like
small.
everybody else. We're just like
Yeah.
everybody else.
so. Bringing this around, it seems like there's, still everyone online, and we've heard this over again week after week that this online component is pretty important, especially to people that aren't live in Dallas and can't drive as easily. So what does it take? Do we need to just have like a side board meeting of DPRG and vote on?
That'd probably be the way to do it, and figure out, like, I don't know what meetup costs, because that'd be something, I don't know. We just have to look at what we want to do in the future. I mean, I know with you going out, Carl, that's kind of like bad timing, but we have to take a look at it and just do
You make it sound like he's on his last legs.
Huh?
You make it sound like he's on his last legs.
Well, it's just like, a major rework that, as he's walking out the door. We'll just have to just have a sideboard meeting and see what we should do. But I didn't want to hijack. So let's, who was next?
Once Pat's gone, we got in queue, we got John G, then Kumar has some lighter questions. And who wants to get in line after Kumar?
Rudd, did you have? Yeah, I think he
Good,
had his
Rudd.
hand up.
Okay. So let's dive in with John G. What you got?
Yeah, let's see if I can get the right screen shared this time.
Pick a screen, any screen.
So can you see this web page on Adafruit?
Yeah.
Yeah, they've got this interesting little project for what they call the Easy Make Oven. So part of this project that this board that developing with Murray and a couple of others is going to require some pretty small soldering. That RP2040 chip has like a 0.4 millimeter pitch on it, and that's nothing that I want to. I'm pretty good at soldering by hand, but that's just way too small for my skills. So I decided, you know what? I'm going to try building this do-it-yourself oven, and it's basically you just take any toaster oven and you hook up this IoT module to it, this Pi board IoT module, and with a thermistor. And what it does is it monitors the temperature, and it just turns the power on and off through a relay to control the temperature of the oven. So you'll spend considerably less than you would pay for the cheapest oven that you can find for doing reflow soldering. So I launched into this, and one of the problems I ran into right away is, of course, supply chain issues. This controllable 4-outlet power relay module here, out of stock. So I decided, you know what, I can buy I could build my own essentially relay switch that I could use for this thing. So I went to Amazon and bought, let's see, you go ahead and stop sharing here. So I went to Amazon and bought a dual channel relay board and 3D printed a box for it. Let's see if I can get it. I always mess this up in terms of where the camera's pointed. All right. And just finished printing it, putting it together tonight, and I plugged it in and it did not catch fire. So,
winner, chicken dinner. Yeah.
So I haven't tested it with the oven yet. I do have this pie board, which I mounted on the cover of my box. There's a pie board IoT controller with a display. And they've got a thermistor amplifier board that I mounted on the back.
Is it's a thermocouple, isn't it?
Yeah,
K-type thermocouple.
Yeah, it's a thermocouple. It's a K-type thermocouple. I don't know if you
Okay.
can see that. That's
Okay.
So we'll test it later tonight and see if it actually works as advertised. I did have some
Cool.
fits. I did have some fits getting it, getting through. I'm a complete noob at CircuitPython. I know Python, but CircuitPython is completely new to me, and I couldn't get the board flashed and running it correctly, and I had to go back and forth with Ada for a few times, but I figured it out myself. For some reason, that thermistor amplifier board, which is an I2C interface, if you run it at the 5 volts coming off that relay, if you run it with the 5 volts coming off the Pi board, it locks up the I2C, and so you won't, if you're in Windows and trying to mount the flash into Windows to flash the board, it won't come up. It just basically locks the thing up. So I finally figured out, well, I did see some note about trying the 3.3 volts out of the Pi board instead of 5, and I did that. As soon as I did that, it came up, didn't lock up, and went and proceeded with it. And now I've got the display. I have the display come up, so I know it'll run the software. So now it's just a matter of trying it out.
Cool, real cool. Mm-hmm. So do you have an oven yet?
Yep, got just basically your run-of-the-mill Black & Decker toaster oven.
Yep.
Yeah, a pretty cheap oven. As a matter of fact, the latest version that they sell on Amazon tends to catch fire. I've seen a few posts on Amazon that reported that brand of oven tends to catch fire a bit. So
Okay, one thing I will say here, because I've done this a couple of times, is you can buy those very inexpensively, those and other brands, and sometimes you can get a really top-notch brand at the Goodwill stores for, I don't think I've ever paid more than $15 for them. So that's another source. That's another source to take a look at for
I've seen these
toaster ovens.
We got these stores that have cropped up around here called Ollie's, OLLIE''S. They're
Yeah.
selling all this stuff dirt. I say it's selling like 25 cents on the dollar worth of stuff. It's not a dollar store. It's like overstowed and overstocked.
Yeah.
They have a bunch of those little countertop appliances like that. That might be another source as well to get one of those things cheap and just burn it up.
Yeah.
that's not a brand new oven. That's actually my old. I've had this oven for a couple of years or more.
Okay.
And what I did was decided, okay, let me use this oven. It was a fairly cheap oven. Use this oven for my reflow soldering, and I bought a new oven with better features on it for toasting stuff.
Yeah.
John, I have a question. I've read articles about this, but I've never done it myself. But a couple of years ago, Ron Grant designed me some boards that had to have these little tiny capacitors on it that I could hardly see, much less solder in place. So I took it up to work, and Art Endress, one of the engineers at work, had a toaster oven and painted all the necessary places with a solder paste and set the parts down with tweezers. He said we didn't really have to be that accurate about how you set them down, because when it melted, they'd float and square themselves up, which they did. And then he put it in the toaster oven and he just watched it. And at a certain point, he said, okay, that's all silver and shiny. Now we're done. So my question is, the thermocouple and the switching on and off of the toaster oven, does that just replace Arthur Endress's eyeballs?
Yes.
Pretty much. The problem is you can get away with that a lot of the times, eyeballing it, but you can overheat the parts. You can stress the parts if you shoot over the temperature. I mean, those ovens are notoriously bad at actually controlling temperature. The temperature they show on the knob is probably off by, who knows what percentage. So I've actually done with this toaster oven, I actually did one technique where I had one board where I needed to it didn't have any pins on the outside. You can only solder, do reflow soldering with it.
Hate those guys.
Yeah, I actually did that once by hand and sit there and basically turn the heat on and open or close the oven door while I'm holding the thermocouple in there and watching the temperature, to get it to approximately follow that desired curve. Because you can go too far over, you can go too far under, get bad soldering. If you cool too quickly or heat too quickly, you can break the parts via thermal shock. So there's, with doing it by eyeball, there's lots of ways it can go wrong. And with the pitch on this RP2040 part, I just wanted some more certainty.
Yeah, I'm not, John, I think that's great. And I've thought about doing my own thermal. I mean, I'd probably follow a very similar path that you are doing. One thing though I've noticed is to me it was new. A lot of people are now advocating hot plate.
I've talked to at least one person who uses a hot plate to do that too.
Yeah, so I'm not sure if there's any attempt to control it or whether they're just using eyeballs or what, but I know that if you start looking at reflow, you'll find that there's a growing community of people just using hot plates.
You mean like that you make waffles or pancakes on?
Same principle. I don't know if they're custom made hot plates. I'm sure with the person who did it in the beginning and the ones that do it as a hobby probably just use, good old hot
I've seen
plate.
some Attendees and Instructables basically get a cheap clothing iron and kind of knock off the top and flip it upside down and use that as their heat source of those plates.
Yeah.
Yeah, I've got one friend who actually uses a heat gun. Basically it's a souped up blow dryer essentially that shoots really hot air.
The problem with that is it'll move your chips. That one I wouldn't recommend at all, unless you're trying to take the chips off. If you're trying to rework a board, then it makes sense.
Yeah. It's from what I've read, the heat guns are commonly used for reworking.
Yeah, this is an Adafruit board for I think a TSSOP, a 28-pin part. It's actually for driving motors, and I tried to solder it onto this little board just using it was, I guess, to remove surface mount parts. It was at the makerspace, and it was part of a soldering iron, and you could dial in temperatures and stuff. It was basically a hot air gun, and the watching it until the solder turns shiny turned out to be way too hot because it got to be shiny, and then the part didn't work anymore. So and I stopped heating it, but it was, it was just out of control. So it fried the part.
Yeah. So they, for a certain mix of solder, there's a certain mix of tin and lead.
Right.
They've got a temperature curve that you have to follow. Basically, you ramp up a certain number of degrees per second up to the soak, what they call the soak zone or soak temperature, and you hold it there for about 2 minutes to allow the heat to get into the parts and
Right.
everything stabilize. And then you ramp up again to the melting point of the solder, and you hold it there for no longer than maybe 30 seconds to a minute. I hadn't looked recently, but yeah, that you have to follow that curve to ensure that you get the good soldering joints and that you don't break any parts.
Yeah. I think like a lot of the maximum junction temperatures for thermal dissipation in a part is like 150 degrees C, which I think is quite a bit less than the melting point of solder. And I don't think it matters which way it gets there, either, running current through the part and heating it up so much it gets above 100 degrees C, or just, sticking a heat gun on it and getting the internals of the part above 100 degrees or 150 degrees C. So either way,
and the junctions would come apart then, however the heat is created.
I think so. Yeah.
It might not be the chip. It might be the chip to the
wire.
the bonding
wires or
that,
something.
well, I don't know if they even use bonding wires anymore, but that bonding is probably what limits you there.
Yeah. Anyway,
Yeah.
I had a VFD that ran variable frequency drive that was running a motor, and the CPU temperature while running inside the chip with the report back from the drive was 99 degrees C, normal running temperature. And somebody said that, well, the normal running temperature is supposed to be no more than 89 degrees C. And he says, your drive's going to fail. And sure enough, the drive failed. It took 20 years.
slowly cooked it.
That's the standard engineering answer, right? It all depends.
Yeah.
Because I know when I was at Nokia, I never got close to the manufacturing lines for the mobile phones, but some of the guys I was working with would design these 20 layer circuit cards with 5,000 nets, the size of a phone, buried vias, interstitial vias from layers to layers, components top and bottom. And they had to be really careful to make sure that the whole design of it, not just from RF and EMC, but that the power plane and the ground plane distribution were such that when you ran that particular board through whatever process, it was supposed to, that the sides heated evenly enough so that it wouldn't warp one way or the other. And it was definitely a function of the circuit traces laid out in the board, the parts that had to go on the board. And I would be shocked if any two phones had exactly the same temperature profile because, well, we would run because it was crazy. I went from defense industry where we handmade 10 prototypes of through-hole boards. Then we would start the lifetime production of 2,000 units to Nokia mobile phones where there would be, let's say, 6 or 8 prototype runs with first 1,000, then 2,000 or 3,000 phones each. And they would run them. So we would build thousands of phones as prototypes, and then they would go to the shredder afterwards. But then they would build so many of those phones and then take statistical samples of them and run them through the drop tests and the thermal cycles and all these other tests. And then based on that, they would reverse figure out, okay, well, this was the process that was most robust for that design. So you change the design of the circuit and the board and the phone, then you change the design of the production line. And the thing is that like if you changed a part, if you changed a machine, you'd have to go through and requalify the design of the circuit card and the design of the production line to build the circuit card.
But all you need is 1,000 volunteers to volunteer to use phones that might catch fire.
yeah. So then they would, something like that.
Yeah, but the manufacturing volumes like Hitachi we sold the power amplifiers in, well, then it was CDMA phones. You could have, tens of millions of units, that you have to provide to Nokia per month. And, some of the programs that I supported, they were, in the like 40 to 50 million range. So you get that high of a volume. And if anything happened, if they found that your part was causing an issue with manufacturing, or there was some issue, it was it's like, dozens of people would be put on that to find out what that problem was, if it was truly, a problem with your component.
Your component versus that reflow oven was turned on a little too high on that one run.
That's right. Yeah.
Well, it sounds like we have a few people here who have built or may build their own printed circuit boards. I'm just wondering how many of those we have.
Yeah, but they're nowhere.
A through-hole board in the early 90s count?
Yeah, I've done it.
Well, there you go.
But double-sided boards versus a 15-layer board is very different.
Yeah.
Well,
and everything else.
Yeah, I'm still basically way at the bottom, building.
Whoa! If you're not wire wrapping, you ain't nothing, man. I'm just telling you that now.
Yeah, I'm basically just the only thing I've done is 2-layer boards so far, and relatively small.
Hey.
So.
Hats off to you.
Oh, come on now, dead bug construction.
Dead bugs. Oh man.
Hey,
John,
I wired power to ground once on a wire wrap board at E-Systems and created an interesting thermal event.
Yeah. Hey, John, how did the spider come out?
I was kind of, I had issues. I basically was trying to solve one set of problems and wound up with a different set of problems. And it worked, but one of the issues I have is the flex sensors in the glove that I was using, that they have these really, really flimsy contacts on them. And basically I crimped those. I used basically some fishing gear to crimp the connectors on the edge of the flex sensors, and some of them have kind of come loose. So that kind of complicates things. I'm sitting here moving the glove, and then a loose contact on one of the flex sensors, and the leg stops moving. I have to work around with a glove, and I never fully tuned the current limiter. So I was occasionally hitting my current limit and then having to go back and reset the spider so that it would reset the driver again. But
is he hanging in your shop anywhere?
What's that?
Is he hanging in your shop anywhere?
No, he's in the other room, sitting on a table in the storage room.
I'd like to see him. You were going from servos to stepper motors, right?
No, actually, the very first thing I tried, actually a couple of years back, was servos, and I still have this hanging up here. I mean, you talk about a journey. The idea I started with was balsa wood with these little cheap servos.
Yeah.
With fishing line to operate the joints. That was the initial idea. Well, that didn't go anywhere. Finally decided to get those 12-volt stepper motors and still had to use these, not fishing line, but essentially a bowstring to operate the outer knuckles. But still had a problem with the power, not quite enough power to overcome some of the forces needed to move the leg. And that's when I finally decided to go to brush DC motors, the little Pololu, really tiny micro metal gear motors.
Okay.
And then instead of trying to use a line to operate the outer joint, which was always a problem because it never could quite get the tension right, basically each segment of a leg is a linear actuator with a little worm screw in it.
Okay.
It basically worked, but it really wasn't a massive improvement over the stepper motors.
Okay.
There we go. All right, well, that's basically it. And I will say the only thing I'm planning on smoking this holiday is a turkey. And do you have any idea how many rolling papers it takes for a 5-pound turkey breast?
How many what?
Rolling papers, smoke a turkey?
Quite a few, I would guess. Yeah.
Okay.
And then what kind of headache does that leave you
Ka-ching.
with, John? I don't know.
I'm done.
Okay,
Move on.
cool. Well, that's cool stuff. Practical assembly. It'll be really neat to follow your project with that oven and see where it goes and how you tie it together with that custom circuit card and stuff. So.
Well, I have all the parts except for the actual printed circuit boards I ordered from PCBWay for our prototype, and I'm expecting those any day now. So I've got the oven assembled at just about the right time.
Cool. Nailing it. Okay, next in queue we have Kumar. I think you had some LiDAR discussion that you wanted to take us through.
Can you hear me?
Hello, yep.
So I've been very enamored by the LiDARs, and finally about 2 months ago pulled the plug and got this A1 M8 RP LiDAR. And initially I just wanted to get it running, connected to my laptop and get it running. Doug told me exactly what to do because he had one, and then I tried it, it worked. And then I wanted to get it connected with the Raspberry Pi, and Chris pointed me to various things, and I got that working as well. But I have never used a LiDAR. I have never used the feedback from the motors to get the position. And then this weekend, I did my first mechanical assembly of taking the LiDAR, the Raspberry Pi, and the TFT display, and created a small board, which is the board on the top, and mounted it on top of my Elegoo smart motor, smart robot. So the bottom is Arduino Uno based robot, and it comes with Bluetooth as well as the infrared, and we can make it move, create patterns, do whatever you want. And the top is completely independent. It's a board with a battery, a LiDAR, a TFT display, and a Raspberry Pi with its own power supply. So as I've been playing around with it, and this is based on standard off the box from Adafruit, and you just run a circuit Python. But if you follow the instructions, 15 minutes, you have the RP LiDAR up and running. If you try putting your own Linux version, 1804, 1604, try to do ROS, you will spend 5 weeks, you will not get it running. While if you just take Adafruit, Circuit Python, RP LiDAR, 15 minutes, it's up and running. So right now, one of the experiments I do is I take this LiDAR and keep something in front of it. And if I keep a static element in front of it, it measures perfectly the same distance from the robot to that thing up to 0.1 millimeter again and again and again. As it rotates, 142.1, 142.1, 142.1 at angle 1, 139 at angle 5, and 139, 139, 139. So as I look at that and I say, what are the different sensor people use and why do they use it? They use an infrared sensor to find out whether there is an obstacle nearby. I don't need an infrared sensor. I can use the RP LiDAR based on the direction to find out how far it is from an obstacle. People use limit switches to give a hard stop. I don't need a limit switch. I can still use this. And the other thing I was really thinking of is if I want to navigate through a door and I measure the distance to the two sides and I say, I want to keep it equal and then provide a control and it can move through the door. And these are things which are going through my head since last weekend. But the thing which I've been enamored with is I want to get a map of the house. And that's really mapping as part of SLAM. And there are multiple options. People say, go ahead and get ROS, you get SLAM as part of it. But getting a ROS itself is a problem. So what I was thinking is, if I know where my robot is, and then I move some distance, let's say I have a wall in front of me and it is 300 millimeter, and I move a distance and it becomes 280 millimeter, and it is a fixed static object, then I know my robot has moved 20 millimeter. So instead of having encoders to determine how far away it has moved, can I use the LiDAR itself as an encoder equivalent? And these are the thoughts I have in my mind. And the more and more I look at it and see its capabilities, I'm like, this can do so many things: obstacle avoidance, wall following, wanderer, any of the things we had talked about when I last asked the question, that just this LiDAR alone can help me do a lot of things. So do I have a question? The question is, I don't know what challenges I'm going to face when I move
A
forward.
lot.
And Chris mentioned one thing, which is that when you are, and he just said it in the beginning of the meeting, and he said, as long as the LiDAR is stationary and not moving and you have an object you can measure, but what happens if the LiDAR is moving and there are some problems out there? So it was just an open-ended statement. I want to play more with the RP LiDAR, but I guess there are a lot of gotchas which you guys have seen before, and I just wanted to throw it out there.
Well, just a quick thing is the reason why people use all the other sensors is to provide a defense in depth. Okay, because your sensor, what if your sensor gives you a bad reading or does no reading at all? All right, for example, in your case, you're spinning, okay? If you're coming up against a wall and it hits the wall, the LiDAR for that thing, and then bounces off, you won't get a reading. So you'll see dot, 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 space, space, but nothing. Dot, dot, dot. So what's over here, you don't really know what's going on. So what you want to do, and so you want to make sure that you have some depth to your defense, because you don't want your robot running into things, right? So that's why things like the IR sensors, the bumper, ultrasonic, they all have weaknesses. All right. And what you're really trying to do is find how to get the most coverage, sensor coverage, as easily as you can. Now, and the thing is that LiDAR you have on there might be able to get 10 I can't remember. I think it's 10 revolutions per minute or no, per second or something like that. Isn't that it, Chris? Is it 10 or 5?
It's, for the cheap one that he has, it's 5 to, you can crank it up to 7. At 10 it starts to vibrate. The one I have, the more expensive one, kind of starts at 7 to 10. You can crank it up to 20 if you can, mount it on a heavy enough platform.
So, okay, so on that robot, I think you have a 70 millimeter, roughly a 70 millimeter wheel.
Revolutions per second?
No, it's
complete scans per second. So yeah, it amounts to 300 RPM would be the 5 complete rotations per second, right? So
so let's say you have 5 revolutions per second, and by the way, that's a real large amount of data, okay, for you to process. So you got to have something that's processing it pretty good. And
but when you talk
so,
about
how big is your wheel? Your wheel is what, 3 inches?
2.5
75
inches.
about
2.5 inches. 2.5 inches.
Okay, so let's say 60 millimeters, right? So 60 millimeters times 3, roughly, instead of pi, just 3. So that's 180 millimeters, one revolution. If you're, so that 180 is going to be, give me a second here. 3, 4, 7, roughly 7 inches per second. Okay. So you're going to look at it 5 times. So that means your robot's going to move a little over an inch and say an inch and a half per reading. And that's at a pretty low speed. What if you're doing, 20 or 30 inches per second, which you might be doing in a contest, you might easily be doing that. And if you're doing that type of speed, it's like, imagine you're looking and then you close your eyes for 2 seconds and then open them up and then close your eyes for 2 seconds. If you were driving a car, eventually you're going to get yourself in trouble. So there's definitely LiDAR is a very cool sensor. It can add an awful lot to it, and it can help for mapping. I think it's probably the primary sensor that people are using for mapping. Okay. But you got to, I'm just saying is just running with a LiDAR by itself may not be the best strategy. That's all I was trying to say.
I haven't used a LiDAR before, but I assume doesn't it sweep out just a single line? It doesn't actually have an angle.
Oh, I wasn't going to mention that, but so
Yeah,
Dave would
LiDAR.
usually call you out on that. For example, you remember when I showed this bumper on this particular model? What was his first case? Well, that's only covering a half an inch. What if you got something coming underneath or you got something coming over it? You'll never see a bumper. And he's right. But the point of it is, I probably catch 90%.
Well, that's what I was going to say.
Yeah.
I'm
hoping that the bumper is not really ever going to hit. In a perfect world.
I think your strategy will work for about 90% of what you want to try to do. LiDAR, as Chris has pointed out, there are certain things you won't get reflections off of. I've got a black leather attaché case that it can't see at all. And so by the same token, as John was saying, you're really having a one-dimensional slice of your space. So if there are things above or below that, you don't detect them. However, having said all that, that's probably another 10%. So make all that working that you're talking about, and then you're going to say, oh, now I see why I need a bumper, or, oh, now I see why I need a more general coverage avoidance sensor. But a lot of what you're describing, I think you can do that way.
Mm-hmm.
When you talk about a 90% success rate, it reminds me of the reason that some people won't buy an electric vehicle based on what they tout is they say, well, the average driver drives only 35 miles a day, so you don't need that much range. Well, no, you do. You may drive 35 miles a day 95% of the time, but that one time that you need to drive 200 miles is the one that matters. So 90% is not good enough. 95% is not good enough. It's got to be way, way higher than that.
My experience is that it takes a suite of sensors because, as Doug said, they all have their blind spots, their failings. And that's why we had jokingly referred to an actual physical bumper like Doug has there as the sensor of last resort. That's because if you run into something, that means everybody else failed.
I think the fact that this is not the sensor is understood. And when I said I can not have a bumper switch, it was not that I ever will not have a bumper switch.
Oh, no, I understand.
Or not that I will not ever have an encoder. What I was trying to say is that lot of what those things do can be experimented, and like people said, in 90% of the cases, it may still do the job and not do it for the remainder. Yeah. And the one thing which I specifically, when I was thinking about mapping and what I was grappling with is this idea of knowing that there is a wall, it is 300 millimeter, and you move something and now it is at 280 millimeter, you are actually doing a mapping as well, because you are finding out how far away the robot moved from the original position, and at the new position, you again find a mapping. So
but it's more localization. What you're describing would be referred to as localization, right?
Yeah.
Because now that the obstacle is closer, so you can say, yeah, I must have moved 20 inches if I'm suddenly reading something that's 20 inches closer. You're right.
I don't have an encoder, but the wall is nearer to me. So I say, hey, you are right. The word is localization and not mapping, because finally, in order to do mapping using a LiDAR, you need localization. And normally you use an encoder or something to do the localization and then apply the LiDAR to actually build the map. But now I'm mixing the LiDAR for mapping and using the LiDAR also for localization.
Yeah,
Of course,
but-
that is
but-
exactly what Chris demonstrated to us a few weeks ago.
yeah.
I
Yeah,
think
and
that's
to-
better.
And what I was just already pointing out, either directly to Kumar or in the list, right? That the path you're heading down, Kumar, right? It sounds like you have a desire to create certain algorithms from scratch, and some of it is conceptually straightforward, but you're heading down a path that requires quite a bit of algorithm wizardry, and it's a lot more effort to. I think it's in the end a lot of effort to even implement a seemingly simple scheme, because I kind of had a similar train of thought, 5+ years ago when I first started with it, and maybe I wasn't using the Pi yet. I was trying to extract useful information from the LiDAR without going, full out RAWs. But it's not as straightforward as it seems, I think.
And Chris, I don't want to do wizardry. In any forum or wherever I have reached out to people, and the moment I say RP LiDAR, there is no response. You talk about anything, there are responses. And normally, if somebody points me to a link and say, here is a tutorial for how you will do it, I get no links. So when I don't get that, I don't see a lot of people very active. And if somebody said this GitHub link will help you go there, I don't want to build a software which already exists. But there are no links. People are not pointing me to actual links.
I think that
there's a lot
backs
of
up
hand
what
waving.
Chris says. That's
Lot of
backing
hand
up. They're backing up what Chris says. It's hard, and that's why you don't see very many people. Now,
Well, let's not dissuade him too much.
Well, I mean,
I want to say,
no, I don't want to.
Kumar, I am happy that you are.
Yeah,
enchanted
go.
with this.
Yeah.
Yeah.
No, because
you sound thoroughly enchanted with this device, and go for it. It's all
Yeah.
good.
Yeah, but I will say one thing here too. I'm going to give you two scenarios. All right. One, I'm going to measure the
Carl, you are on
speed.
mute.
You want to measure the speed of my motors, and I'm going to use an encoder. Okay, that's pretty straightforward, right? Now, if I want to measure the speed of my motors so that I can control them now with the LiDAR, first of all, my sample rate is less, plus the algorithm is a lot more complex. So I'm just saying it may not be the best tool to do some of the things that, yes, it can do that, but it might not be the best tool for that. All right. But I would really want to encourage you, because like I say, it is hard, and any progress you make, we will gladly listen to you. I mean, we will soak it up like a sponge. So yeah, I don't want to discourage you at all. I've got that same unit. Well, no, I got an older one, but the same type of unit, and I would love to see it. Now one thought might be is, and I've seen Scott do some of this. He's first, instead of really trying to do mapping and
simultaneous localization and mapping.
Instead of doing localization, he first started off just trying to detect where objects are. Where just can I use it as obstacle avoidance? That's a much simpler problem. Yep. And you can gain some useful information there. But to do that, you're going to overcome all of the handling of all of that data. For example, you're going to have to take the you're going to have to take what is it when the polar coordinates and turning them into rectangular coordinates on every point that you go, so the X, Y. And, there's a whole lot of processing that you have to learn how to work through to get.
So right now, out of the box, at any position, I can get the polar coordinate, the distance, the X and Y, all with simple math, and that's already coming
Yeah,
in.
yeah, yeah,
right
yeah.
off the
No,
bat.
I'm just saying but you got to do that
Yeah,
for
yeah, for
every
every
point,
angle.
every revolution.
Yeah, on a Pi, that won't be a problem, right? I
It's
mean,
a very
Okay.
easy thing,
if you
actually.
tried to do that on an 8-bit micro, well, there's
Yeah,
no
it's gonna
way.
be a pain.
On an on a Cortex M4, yeah, you can probably do it. On a
Yeah.
Pi,
Well, they
you know, it's
obviously do it with a Nito. So yes, you can.
Yeah.
Yep.
So
Well, even compensating for the changes in distance, when your LiDAR is spinning and your platform is moving. Chris, you talk about, how that's distorted, and if you don't compensate for it, you don't really get.
Yeah, but again, it's a little bit of a corner case, right? Before you even worry about those things, which you worry about if you want to make your robot go fast, before you even get there, it gets already complicated. The moment you talk mapping and localization, and Kumar, the way you're talking sounds like you want to create it from scratch. It's I think my advice in to you was, right, find some libraries, and again, you're not going to find something that does exactly what you wanted to do, but you will find libraries out there that do the occupancy grid piece, but you got to figure out how to feed it with the data that this library expects. You got to figure out how to integrate these libraries and put together what you want to put together, and that can be a lot of work too. uh, the localization piece, there are libraries out there that do that, outside of the RAWs context. You don't have to go full out RAWs just to do SLAM. It's not, RAWs is not a prerequisite to do SLAM. But again, you have to put some of these building blocks together yourself, by hand, where they're already put together for you. If you go the RAWs route, that's the difference. So you just find those libraries, put them all together, integrate them, manipulate the data, move it around, and it's still a lot of work.
Yep.
Kumar,
Okay,
you
guys.
said that the links you found, or the lack of links you found, and I said there's just more hand waving, and which we can fade off into hand waving pretty quickly. So I'd like to offer some. I actually made an occupancy grid system work. This was a number of years ago. It's a little different than what you're describing, because the robot that I had already had good odometry, so the localization problem wasn't there. And I didn't have a LiDAR, but I had stereo sonar, and the robot can spin in place. So basically it can do the same thing. And so I created an occupancy grid. I assumed that the grid was 6-inch squares. And anytime I got a reflection, I incremented the value in one of those squares. And then I set some threshold to say you have to get this many hits before that's considered a real.
So if you can point me
A
to
real-
that, there are a couple of changes I can make based on what you said. Even if I today don't have odometry, I can say time and moving at some speed, therefore that distance, which is not true distance, but it is inaccurate, but that's a measure of distance. And I can use the other things. And the second thing you said is there is this rotating thing, which is finding out the distance, and that's being done by the LiDAR anyway. And the third thing you said is you're assuming a 6-inch grid. So if there is some code or GitHub link which you can send, I can take and adapt it.
Well, all I can do is wave my hands.
But I would really
you're saying you
advise
have
you.
done that before.
But I have to tell you, my take on all that was that building these maps, and I had several of different spaces that I'm able to run in up at work, and then using those maps to navigate, I found didn't work any better than the kind of navigation I was already doing. So here's a whole lot of extra math and data structures and all that stuff. But the proof's in the pudding, which was how well did the robot navigate. So you can get your robot to navigate and avoid obstacles without knowing where it is or doing any kind of localization.
Yeah, but if I have
Just
to go
using
from
the
my kitchen
LiDAR.
to my bedroom, how do I know the path to take if I don't have a map? Because
Well,
once I have
that's-
a map, I can create a path.
I would say from what I'm describing, that's a couple of steps down the road. That is, you need to get some other pieces working first. And an easy piece to get working is just to use that LiDAR to do obstacle avoidance. If you can get that piece working, these have, baby steps. And build from the bottom up.
Yeah, I agree.
I would add to that, you keep saying, Kumar, you don't have odometry. I think it's worthwhile investing time in getting odometry working on any robot, especially a wheeled robot, right? It's, depending on the nature of your platform, it may not be, terribly accurate, depending on the kind of wheels and motors and whatnot you have. But I think it's going to pay off because I think without odometry, I think it's just hard to.
Yeah, I just got two TT motors with the wheels Hall effect sensors connected to them. The only thing probably I need to take those four wires, two wires, connect it and do the logic for the encoders to get the odometer. I've not done that yet, but I think that's also a good idea to get the odometer.
It's worthwhile doing because again, you can do simple, navigation, within the short range and then still not get totally lost. And it'll pay off in multiple ways by knowing how fast you're going, where you're going, more or less. You can't do it without it.
And I know the type of robot you're driving, the smart car type robot. These are TT motors that are direct replacements that have encoders on them.
Yeah, I got them from Spark Fun and they just landed. So I got two TT motors and I can replace these because they are size-wise. But I always thought that the encoder logic is going to be complicated, but I guess you need to spend the time to figure it out.
You just need to find the right library to use it. Again, it's the things that low-level stuff, unless you enjoy doing it, and a lot of people do, you don't have to reinvent the wheel. You find the library, you hook up the pins, the signals to the pins on the Arduino, and you let the library do the work, and you just use the data, right? You don't have to know everything at every level,
Thank you, guys.
Yeah.
It was one of the things that occurred to me, and it's just a thought, but rather than localization, can you use deep learning to train a robot to say, do a scan from some point of the room and eventually say, well, I know what this room is. It's the living room. I know its shape, even from this location.
You probably could. I mean, it's no different than pointing the camera at the path that the donkey car is taking, that sort of thing. Yeah, I'm sure you could. I'd be surprised if people haven't already done that,
Oh, so what you're saying is either with a LiDAR or a camera, create a signature of the rooms which you are in. And when you are subsequently doing deep learning, you say, hey, this one actually is this room, because that's what the signature is telling you.
Surely it's not more difficult to recognize a room than to recognize, a fire hydrant or a bicycle. I mean, it's the same kind of problem, right?
I mean, as long as things in the room are not, as long as not too many obstacles come and go, right? It sounds like a standard sort of image recognition kind of problem, right? To which you can apply one of the many solutions that are out there. So it seems like it should work. But it'll tell you which room you're in, right? It won't tell you, I don't think it'll tell you the coordinates within the room.
Yeah, multiple options to play.
Well, that's your assignment now.
Thanks for the assignment, John. Thank you, guys.
Boy.
Okay, that's all I had.
Yeah, that's cool.
That's cool. That's
looking forward to see
good thoughts. Good thoughts.
What targets you pick and how you head down this journey. Yeah, cool. Okay, so next we had Rudd, and do we have anyone who's ready to go? Okay, Harold's got something after Rudd. Anyone after Harold? All right, so Rudd, we'll pass over to you. What you got?
Okay, well, I took my RVR, and this is a SparkFun ESP32 thing. So that provides a Wi-Fi to serial interface to the rover. And I wrote the code on my PC to communicate through the Wi-Fi to provide all the commands to the rover. So now it's independent of the serial port cables that I had to use previously. So now give you a short demonstration here. Present now. A window. And this is the rover moving under command of my PC. It's just a pattern that I've hard coded.
Is the pattern running locally on the robot or through your PC?
It was through the Wi-Fi. The code was running on the PC, but sending the commands over the Wi-Fi link, and then out a serial port to the rover, and then getting the responses back also from the RVR. So it was a two-way communications using Wi-Fi. It gives me a lot more opportunity to play with things since it's no longer tied to a cable.
So, and you said in the mailing list message you're planning to add a Raspberry Pi and you have concerns about the power draw, right?
Yeah, I'm gonna have to wrestle with that. I've got some power packs and so forth. I'll probably have to use those. One of the things the RVR has, the rover has is a go-to location command, and that's basically what was being used here. It was starting at 00, go 3/4 of a meter ahead, come back, and it could do that either by turning entirely around, coming back, or just reversing. So it's got a lot of flexibility as far as the API that they provide on the rover for driving it, and that's just one of the types of drive commands they provide.
So they have odometry built into the platform, sounds like.
Yeah, there's a lot of commands in there. It's got encoders which do the data, distance measurement.
Do you know if it has an IMU as well? Because if you turn on a tank-driven platform, I don't know how accurate your turns are gonna be, right?
I'm sorry?
Does it have an IMU as well, or just?
It does have an IMU. That's what it's using for the turns. If I say turn 90 degrees, then it uses the IMU to do that turn.
Did you use ESP now?
I'm sorry?
There's a thing called communication method between two ESPs. I think it's called ESP Now, NOW. Did you use that? It doesn't sound like you did.
No, this is one of the earlier ESPs, ESP32. It's just I think it's basically the first one that came out.
Yeah. So you used basically let's see, how would you say it? I don't know which standard it is for Wi-Fi. It's one of the 802.11. I don't know, EFG. I don't know what it's up to these days, but
I don't know what level it is. It's just a TCP connection.
Oh, it's TCP. Okay.
Yeah, just like internet.
Mm-hmm.
Going through my household router.
Mm-hmm.
So it sounds like you telnet into your ESP, and then that gets you to the serial port of the ESP, and therefore to the rover. Is that correct?
Right. Mm-hmm. Yep.
So what's next on your build agenda? I mean, that's gold star material right there.
Gold star.
Yeah.
I'm not quite sure. I think I'm going to wait until Black Friday or Black Monday and see what shows up on some of the websites for other possible boards or processors to use. I do have one of those 3D cameras coming from that Kickstarter. So that's one of the reasons why I need to get something a little bit more powerful out on the board, on the system itself. I've got some Raspberry 3Bs, and so I may play with those to see how they work. It seems if you turn off some of the parts on the Pi, like the HDMI port, you can disable it. You can cut back the power usage, and so it may be usable within the limits of the 2.1 amps I can get out of the rover. If not, as I say, I got some USB power packs I can put on there and work with.
Britt, I have an opinion about the batteries. Having built robots with multiple batteries and single batteries, the problem with multiple batteries is that the charging gets out of sync. They don't all run down at the same time. And that became enough of a pain in the ass that I quit doing it. So on my more current robots, I have a big central battery and then a bunch of DC-DC converters. So there's only one battery to keep track of and to charge. It really is a pain to have multiple batteries.
But you're talking about multiple battery packs or cells?
Packs. I mean, yeah, clearly, like the LiPos or 6S or whatever. And you said earlier, Chris, that you were using nickel metal hydride, and they have a fond place in my heart, as I mentioned last week, because they don't catch on fire. But also next to lead acid, they're really the easiest to charge. They don't have the memory problems. You can top them off anytime you want. It doesn't damage them. They're real robust. They have enough internal resistance that they're not as dangerous. You're not going to arc weld with them.
Yeah, agreed.
Problem I've got is the rover's got its own internal battery, so I can't really work with, and it doesn't allow charging for externally. You got to take the battery out to charge it.
Does it have a USB port where you could steal power?
Yeah, it does. And I'm stealing power off another port on the board right now, but that is limited, as I said, to about 2.1 amps is their recommendation. So anything beyond that, I'm going to have another battery.
I mean, you should be able to power the Pi from that, right? I mean, it's only occasional surges that you may have to deal with, and you may have to add some bulk capacitance, right? Some big electrolytic capacitors, to the 5-volt rail on the Pi, for example. I always find myself having to do that, so it doesn't complain about under voltage detected. Oh, voltage back up, under voltage detected. But it's not like the Pi is gonna consume 2 amps all the time, right? That doesn't need that much. You're not, like you said, you can turn the HDMI out. So I think you should be fine.
When I was measuring it for my other robots and stuff, and my stuff that I got going on, I got my Pi 4 clocking in an amp, maybe, usually 0.8, 0.9. When it got real busy, it got to 1.4, that kind of stuff. So your mileage will definitely vary on that, right?
Well, part of it is if I add additional sensors like this 3D camera, those are going to start drawing power too. That's where I get a little bit concerned.
How about for weight? Does it seem like it has enough mechanical power to take much extra weight on the thing?
I think it does. I haven't tried it out, but it's pretty powerful.
Was there something special about the platform that caught your eye, like the fact that it was treads, or highly integrated, or how did you pick that in the first place?
It was the integration. I mean, basically, I was trying to build something like this using a Wild Thumper chassis, which is wheels, 6 wheels. That's what I used back in the one competition for NASA. But since this came out and it was the right price, and I got it at the Kickstarter price or whatever it was they ran it on. I said, heck with it. I'm going to get this one. And
How much did you pay for it? Because it retails now for $250, I think, right?
yeah, I think it was like 175, something like that. I can't remember. It's been 2 years. And I'd rather work on software than hardware.
Kit bashing sounds good.
I very much appreciate the buy it if you can philosophy, especially as I droop into old fartdom. $250, you know, how long would it take you to make that, you know?
Exactly.
So
Yeah, I had been working for years on the other, and just got me where I wanted to be. Then I spent a lot of time doing the software.
Scott and I went through this same thing when we were first exposed to IMUs that were reasonable, because we had both spent about a year trying to, you know, learn the whole world of MEMS circuitry and the Kalman filter, extended Kalman filters and all that. And we both kind of came independently to the same conclusion, which is that there are people who eat and sleep this stuff. And I have a year of work. I haven't been able to come anywhere near what I could buy from them for a few $100.
That's where I kept stumbling on the IMU stuff.
And the first IMU I bought was $800. So the fact we can get one for 20 now, five, okay. Ray, I had a comment for you, if this is a good time. We were talking last week about, I described my father's old International harvester tractor with the two brake pedals.
Yeah.
And as I was picturing that in my mind the next day, it occurred to me that the reason that works is because you had this enormous steering wheel and you could steer those little two front wheels all the way over to 90 degrees, which I don't think you can do on your motor.
Yeah, I probably can't go 90, but I think I can go pretty close. Or I can just take that whole front assembly off and put some casters on it that, you know, free float. So
Yeah, it just occurred to me that you didn't have to just hit the inside brake. You had to, you know, turn that
crank
big
the wheel,
wheel
yeah.
and get it at 90 degrees.
So that those tractors would actually spin on the wheel. You didn't get any forward motion out of the.
Yeah, you could just break the inside wheel and
Yeah.
turn around, and you're automatically lined up for the next row.
Yeah, next row. Yeah. Yeah, there's
Drove a tractor at one point to cut the grass at a big football field and soccer field area. Had the double brakes on it.
Oh, okay. Yeah. God, I can't think of the name of it now. It's basically a piece of machinery to cut heavy brush, and they actually, instead of a hydraulic transaxle, it had a manual transmission on it, but it also had brakes for each side of the differential. And so instead of trying to manhandle the thing and force it, left or right, you could just squeeze one of the hand levers and actuate a brake on either one side or the other, and steer it much easier that way. I can't think of the name of it now, though. It'll come to me. But that's kind of where I got the idea, and the only place that I found brakes that I think that would work is Go Power Sports. They actually sell stuff that you can make go-karts and mini bikes out of. So they even have hydraulic brakes if you want to spend the money for hydraulic brakes. So, but yeah, that was going to be the next experiment to see if it was a little more, because you can't really guide it with Ackerman steering because it's you can't spin on one wheel, or and that's really what I want to do is, be able to turn like a zero turn basically. So,
I just looked at Go Power Sports webpage. How fun.
oh yeah, all kinds of stuff. They've got rack and pinion steering mechanisms and all the wheels and hubs that you could ever want. Yeah.
Plus, as a new user, I get a 10% discount.
Yes, yeah, you would. So,
Oh, there's some toys in your future, David.
yeah, yeah,
Cool.
yeah.
Tractor Supply gives a 10% discount. I think it's on anything in the store on the last Tuesday of the month or Thursday of the month for anyone over 55.
All right. Yeah, but I don't know. I'm assuming you might be able to get, like brakes for a Ford 9N or something, but I don't need brakes that big.
Oh, big wheels, gears, chains, stuff like that. If you're building larger robots.
That's one of my most fun stores to go to, especially when they get the load of chicks and ducks in for chicklings and things. It's almost better than going to the zoo. I go in there, I check them out. It's like, okay, never mind. Okay.
We never had any livestock in Canada. Just the hardware and the farm gear and stuff like that.
Okay, so I think
Yeah, I go to either surpluscenter.com or statin-inc.com. Statin makes motorized bicycles and motorized wheelbarrows, like for moving concrete. They're kind of like all-terrain vehicles, and he's been making gasoline engine driven and he's probably been making the gasoline engine driven bicycles for a lot longer than he has anything electric. I think that's still his mainstay is gasoline engine, but he's starting to get into electric bikes now too. So, and he has his own machine shop and can pretty much make anything. But surpluscenter.com I haven't been able to find anything as reasonably priced as what I can get off that website, especially for like, keyed wheels and, stuff like that, or larger wheels. So they, in some cases like Northern Tool, they have kind of a, limited stock in comparison, but the bad thing about like surpluscenter.com is that, if you buy something and you like it, the next time you go to buy it, it may not be there because it is surplus stuff.
Here's a 5-ton electric horizontal log splitter for $249.
Oh, on surpluscenter.com or something. Yeah, there's all kinds of junk there. I mean, they even had they were electric seat motors that you had access to the back of the motor, so you could put an encoder on it, and they were cheap. I think $15, for a little 12-volt motor. So, and I could put one of the Polulu encoders on the back of it. For less than $20, you had a pretty good setup, and it's pretty powerful, and had the right RPM range and torque. And so anyway.
Cool. All right, I think we have Harold next, and then after that, Kareem has an appeal for his team. Anyone want to queue up after Kareem?
I have a question that I'd kind of like to ask the group about Windows.
Okay. We'll put you in after Kareem. So I think then, so Harold, take it away. Uh-oh, you're muted, Harold.
I can unmute myself. I've got
There you
that. I
go.
have that technology. Any of you ever heard of a Jeff Traeger? Said he used to be a member of the DPRG. probably a while ago. Anyway, him and a cat named Michael have fired up are trying to fire up a 3D DFW 3D printing. And I went and saw them, and they had some cats over there that were really cool. You know, $500,000 printer printing out a T800. That was really cool. But I talked about my rover here, and they wanted me to come give them a presentation. Well, they got a problem. Everywhere they go, they can find no place to meet. And I've offered up improving, but that's too far to the east. They want to be, you know, mid cities so they can get everybody, you know, the classic DFW problem in there. And I gave him libraries so he could find one, and he didn't like that. And well, I didn't like that too much. But he asked if I would ask. I told him that Dallas Makerspace would be great, but he says he can't get any traction by finding out who can meet there and when and what needs to happen and all that kind of thing. So since I knew that some of you folks knew some stuff, I said you could come on tonight and ask. And well, he said he was tied up, so he couldn't. So I'm asking for him. Anybody got any ideas where these guys can meet? Because what happens is they get a back room somewhere or a conference place someplace, and you know, like at a Spring Creek or something, and people show up, and then they want to do it again. They're like, well, we didn't make enough money off you or whatever. Now we want to charge you for coming and doing this thing. And so he's not happy about all that. So classic problem. Just throwing out a question for some ideas on that. If you have any, send them my way, and then I'll send them on to him, that kind of stuff. Basically saying I'm supposed to do a presentation on my ExoMy rover because it's all 3D printed, and then go into a couple things on it and that kind of stuff. December 7th, that day will live in infamy, but not because I give a presentation on it. That's a whole different story there. We will have and I told him whether it makes or not, it doesn't matter to me, you know, so that's okay by me. If you may not have one. So, any ideas? Fine. Yes, some ideas, that kind of thing. He keeps telling me how to do presentations already, and I'm like, you know, might want to never mind about all that. That's my personal opinion on stuff. So I'll leave that. But there's that. The other thing that I got going on, and the thing you've been seeing me doing rattle cans on, are things that look like this. So what I did was I was spray painting the stuff so I had the gold and stuff on top, and that doesn't do a whole lot for you, I'm sure. But if I were to put an 8 on one side of it, and basically it comes out to be a flat D20, and you're like, Harold, why would you make a flat D20? Well, it's a long story, but I'll shorten it up significantly because I had some filament to waste. You know, have a little bit of filament left over at the end of a roll. And then you're like, well, why would you want to? And I would do some of these things. And I'm like, hey, I need to use this up. And then after I saw how it was turning out, I'm like, no, I'm just going to do the thing. And so I had this thing sitting around for, I don't know, 20 years. And I'm like, man, I can finally do something with that. And so what I'm going to do is I'm going to get me a little glue gun. This is going to go on there apparently like that, about like that. You turn off some lights here. And then I'll get the other pieces on there in certain ways like this. And we'll have me a D20 on this thing showing up. So hopefully it's, some people think it's a piece of art, that kind of thing. I can't think I make art, but some people thought it was cool, and it actually does look kind of cool when I was trying some of these things out. And it gives me something to do with this thing that I've been setting around for 20 years. I think I got it from Spencer's. I don't know how long ago when, you know, before I got married, because, you know, the wife wouldn't let me buy anything like this now. That's not going to happen. Or at least I could, well, let's just say it's been in the house and she's not found a place to hang it up or a place for it to be displayed on a routine basis. So I'm going to upcycle it. So there you go. That's about all I got, man. That's about all I got.
What's the D20 reference?
Dice.
Are
you playing Dungeons and Dragons?
Okay.
And so you've got 3-sided, 5-sided, 6-sided, or 6-sided is your normal die on it, and then a complete set will have a number of 6-sided dies, a couple of like pyramids, 4-sided dies, and a 20-sided die, depending on what you're doing and where you're going and what you got to roll. Like, and for instance, you need to. You're about to throw a spell at this ice dragon or fire spell. You need a 3d6. You need this many points to make a hit, and then this many more points for damage. So you roll a 3d6, 1d4, and if you get enough, you add up all the stuff that comes on that stuff, and so you get a point thing there, and the dungeon master tells you whether you got a hit or not, and that kind of thing. So that's where that comes from. If you've never played those games, effectively, it was it became like WoW or any of these other kind of run around first person adventure games. Except this is what you did before you had computers that could in 3D graphics to do all the cool stuff. You had to imagine them and actually roll dice for randomness. So in effect though, because the dice, if they're built correctly, are truly random. They're much more random than what I say much more random. They're probably more true random than what we could do in our computers, because we tend to simulate randomness for the most part in various algorithms.
Really, Harold? You have to actually explain Dungeons and Dragons to a group this old?
I'm sorry. Yep. I mean, somebody asked what a D20 was, and if you didn't know what a D20 was.
I mean, I've seen the funky die before, and my brother spent way too much of his life playing D&D, but I never did.
Yeah.
Me neither. I mean, it's
yeah.
And the D20 is in fact a 20-sided die.
Yeah.
And it's a dodecahedron, I believe, or dodecaquadrahedron, whatever the real shape is when you put all those things in it to get a 20-sided die on it. Is John about to show us his dice collection there? Is that what I'm seeing?
Which John?
You started digging around there, John, so I figured you might have a dice collection to show off somewhere.
Oh no! I'm just finishing the assembly of my my relay box.
Oh, awesome! So anyway, I saw that, and everybody saw the other thing I got going on, and you can see this a little bit between I'm going to Disney, so I got my Grogu ears. They're ready to go. I painted them up on the things, and I'm going to wear my glasses. Yeah, everybody seen the glasses, right? Everybody seen the glasses go? Yep.
Last week.
So I'm going to put the glasses in there and have say Grogu rocks or something when it gets dark. And I've got, I tried some UV reactive paint on these, so hopefully they will glow in the dark and do other things, as we're going around places that things show up, and I got a hat to put on it. It should be fun. That's a couple weeks coming.
Very nice. You'll be your own robot in this.
I will be my own thing. I have no doubt when I'm sporting these glasses at the very Merry Christmas hour, saying Merry Christmas and various things, I will get looks. And I think that's an impressive feat to be able to be walking around Disney and getting looks from like, dude, that's cool.
Harold, we need to see you with the ears and the glasses.
No, you're right. I tried it out. So here's the deal. Hold on here. Hold on. You got to, if you're throwing it down, man, you're throwing it down. We got to do the deal. Hold on. It'll only take a second. So let me turn on the glasses. Let me connect up. Because it's got a little control thing here. Yeah. Okay.
Carl, this is all being recorded, right?
I know. Grogu, which if you didn't know, that's the name of the child, Yoda, the baby Yoda in The Mandalorian.
Yeah, Harold's pretty much out nerding anybody in this group at this point.
And that's a feat. I take that as a compliment, by the way.
I feel completely out nerded.
So I need the controller here. I need the color picker. We need a green. Is that a Grogu looking green? Yeah, it is. We'll select that. We got that. So when I'm walking around, I will have my glasses on, my ears on, and because it's Florida and could be hot and sunny, I think I got the deal right here. I'm ready to go.
There you go.
So, I'm ready to go on this thing, and I'm going to be a pretty happy camper.
Okay. Harold, that's awesome.
Needs to wear a robe.
There's a problem with that, believe it or not. Depending in Disney, you got to be careful with wearing costumes and things like that with the robes and things, because and the people that do it, they call them bounders, as in pressing the Disney boundaries, because kids can wear costumes all they want under age of 14. Adults can't, because what they don't want to have happen is somebody walking around that looks like Cinderella that keeps accosted for getting autographs, and they tell them to go screw off or something. Cinderella don't need to be telling people to go whatever, the thing, because they want to tightly control that thing. So adults, with the exception of the not so scary Halloween party that goes on in the evening, aren't allowed to wear any costumes or enough of clothing to make them look like they would be a character in the park. You can have inspired by, and I do believe the ears and a hat's pretty inspiring, but I think I'm with the bounds there if I got my Disney matching shirt on. That the wife said we will have matching shirts every day we go to Disney, and I said no, we're not. She goes, yes, we will, and that was the end of the conversation.
When you go to Disneyland here, Harold, this sounds like fun.
Yeah, December 9th, this will be our first day there.
All right.
It's going to be a heck of a day because we get up I just looking at the flights. The flight leaves DFW at 6 in the morning. And then we get there about 9:30, at the airport or so. And then we got to get kind of checked in or whatever. And then we're going to go hang out to Disney Springs for a little bit because we can't plan on getting in our room till about 3 o'clock in the afternoon. We got a nice dinner, a nice lunch scheduled at a place called the Boathouse. And then we're scheduled to go to the Mickey's Very Merry Christmas party that goes from 7 till 1 in the morning. We will not be there at 1 in the morning. I do not suspect, but it's a hard ticket event. So they kick everybody else out of the Magic Kingdom. So there's lots of Christmassy things to do. I'm going to make sure we get to see Santa Claus and a few other things. And I can't sit on Santa Claus's lap because I would, but because of the COVID. But we'll get kind of close to them. They got a bunch of barriers, so you can't get hugs with characters and all that kind of stuff because, well, the Coronavirus virus and that sort of thing. And so, but it should be a heck of a time, and that's how our first day is. And I think I don't know if it goes uphill or downhill from there, but I will be tired. And
That's
on that
good.
Tuesday, the 14th, I will probably not be on this call, just in case you're wondering.
We have to talk to your wife to make sure there are pictures.
Oh, she's done bought the $200 Memory Magic Maker picture thing. So, if you don't know, everybody takes lots of pictures, and we will take some of our own. But the problem is, there's always one person not in the photo, and that is the person taking the picture. So what they have done is they've got people stationed at very classic locations, like in the front of the Millennium Falcon and the front of the castle and a bunch of other places out there that they will take your picture for you. And because they take them, they all end up being digital, and you can go download them anytime you want. Different price points where we got the biggest thing you could get, so we can download them all we want whenever we take them. All the rides that you go through that has pictures, you'll get all those too. And the fun thing is when you're doing those in-person pictures, they may tell you to react to something like or something like that. And then what they'll do is when the picture gets done and they've augmented the picture with Tinkerbell appearing in your hand or some other thing going on that way, or some rainbow happening, or who knows what else happening in the picture with you. They've got it nailed down. Every way they can get your money, and you don't feel bad about giving away a bunch of your money to them. They got that figured out. That's all there is to it.
They're a well-oiled machine. We haven't been in many years. We're gonna go back one more time, but they're a well-oiled machine, I have to say.
Yeah,
you're right.
Yeah. It's a lot of fun. In fact, I speaking about geeking out and nerding out, I tell everybody that I'm. My wife thinks I'm 4. I think I'm 13, depending on what joke I'm telling. And so I was saying this, and we were talking about the software team I'm on at work. We're going along doing something. It's something I say something off the cusp, or I've got some of my glasses or some other weird thing happening. He goes, one of my team members going to look, Harold, you are a 4-year-old, aren't you? I said, well, yeah, pretty much. Just have a good old time with it, you know. It's never too late to have a happy childhood or something like that.
Congratulations on being 4.
Yeah. Well, I was 3 for the longest time, so the wife thinks I'm growing up a little bit. So
I just hit 64 today.
well, congratulations, 64 times around the sun.
Happy birthday.
Happy
I
birthday.
made it to a nice
Happy
binary number.
birthday.
Oh
Thank
yeah.
you. I think the magic numbers are binary: 16, 32, and 64. And
There
then
you
the
go.
128 is my stretch goal.
That's your stretch goal. And oh, speaking of stretch goal, Carl, are we going to get a shipment come Thursday or Wednesday or Friday?
I don't know. I've lost track now. This is on our.
They said the 25th, and I'm like, that's Thanksgiving, but they're in Australia, so they actually may ship something in Australia on the
We'll
25th.
see.
So I don't know.
Looking good for this year, though.
It is looking really, really
For
good.
Bluetooth oscilloscope dongle probe things that use your phone as a display.
Yeah. The coolness factor on that's way high, too.
It'll be worth the wait. We'll get there.
Yeah.
Cool. All right. Well done, Harold.
I thought I only had a little bit, but apparently I had a lot to say. I don't know how that happened.
How'd that happen? All right. So next in line we have Kareem and then Ray. Kareem, I think you had a request or something for team focus, kind of appeal. You said.
Yeah, my team's looking for a free consultant. No, they they don't have 2 pennies to rub together, but they need your help, and so we're looking for somebody who can give them a little bit of advice. Everybody there probably understands differential steer robots very, very well, right? The team this year has decided to go in the direction of a hybrid robot that has 2 differential steer wheels plus a third wheel that's also driven, that can steer, and it's on linear slides, so it can go in and out of a separate distance from the 2 differentials. And so they've got a complicated steering control system kind of problem, and probably need to bounce some ideas around more than just me. And so we're looking for somebody who might be able to volunteer an hour or so, because it's not a trivial problem. It's not something they can address in a 10-minute interview or something like that. um, so I'll ask again off on the list, I guess, and post it there. But if anybody has any time in the upcoming 2 weeks, that they want to look into the strange configuration, we'd be happy um, to suck up your time.
Well, Kareem, are you looking for like a one on team kind of consultant, or is
Yeah,
what about
that
having
kind of
them
thing.
on to this kind of forum here and see what happens?
So we've done that in the past. We could probably do that. I'd have to check with their specific Tuesday availability. Um, I'm afraid that in fact, that might be the better way to start. And then we'll see if it piques anybody's interest, to go down the rabbit hole, because I don't think consuming 10 minutes describing the problem on this venue would likely lead to um, the kind of solutions that they're looking for.
Kareem, would you elaborate on that now? Could you spend those 10 minutes and just sort of give us a better feel for what the problem space is?
Okay, so was somebody else going to say something? Thought I heard. Um, the robot is their robots all have to fit within an 18-inch sizing cube at the beginning of the match. And so think of because there's sort of a barrier to climb over. It's just a grid of like 1 millimeter, 1 inch PVC tubing on the field that becomes sort of an obstacle. They've got to climb over it. So they've decided to go with these uh, um, large, like 8-inch soft foam filled tires the kind you have on rock crawlers. In fact, they stole it off of the rock crawler that we've had around here forever. And so they're matched on a single axle in a differential configuration, but they each can be driven independently. So it's a regular differential robot, right? So for steering, one goes backwards, one goes forward. Think of it as a T shape. So if you go to the center point on those wheels, that's how you typically describe the center of the robot of a differential pair. And then you go down a ways, and I'm going to shift the robot up, and then down here is a swerve, what we call a swerve wheel. So think of I know Rudd has done some of these. This is the kind of wheel that you have on Mars rovers where they can independently steer, they can independently rotate in different directions while driving, right? Um, so this robot that they're working on has that swerve wheel, but it's connected via a linear slide. So it can change its distance to the center of the common axle. Make sense?
Why?
Is the
Huh?
purpose for that to increase your stability once you're outside of the 18-inch starting box?
It is anti-stability. It is so in other words, it creates a problem in side-to-side stability when it gets very, very long, pretty likely. It's about reach. So you're talking about stretch goals, reach goals. There's a certain challenge of this year's game where it might help to have a very long robot. So the robot so if you think about it, the swerve wheel has an arm on it. So that is a mobile arm that can go further away from the differential pair. And it has an arm on it that's on a turret. And on the other end, on the differential pair, there's a gripper. So there's a gripper there that is picking up objects, transferring them to the arm, and then the arm goes out and scores them in a different location. And it's all about transfer speed. It's a my team always does crazy reach types of things. They're trying to push the envelope. It's not about a rational choice. No team would make this as a rational choice for reliability, that kind of stuff. They're just trying to see what you could possibly do in this kind of game. So I personally, I've never seen this particular combination. It may exist. Maybe it's kind of like forklift. Some forklifts will have a steering wheel on the back, but I don't know if the front wheels are also powered. So they got to get the math right so that whenever the differential pair does something, the other wheel will drive to match it because those linear slides are not powered. It'll just extend all the way out if the swerve wheel, which is the one in between, if it decides to drive all the way out to the end of its reach, that's how it gets out there, by driving there, not by not by the linear slides being activated by some other belt system or something like that. So it all that has, the robot has to have a kinematic model that keeps all of that stuff in alignment, right? And there are other times when, just from an operational standpoint, they want to think about the robot as leading with that swerve wheel, and the differential pair is just trying to keep up with it, right? So sometimes the differential is in control, and sometimes the swerve is in control, and hopefully they don't both try to go in different directions at the same time. But that's the challenge, is that there are even going to be times when they're going to operate them independently. I think we're going to have two drivers, and one is going to be focused more on the swerve, and one is going to be focused more on the differential. So,
Kareem, that sounds really hard.
I'm sensing lots of tiny, twisty. I'm sensing you're in a room with
twisting is a big problem.
that goes in all directions, and there's tiny twisting edge cases every direction you go.
I'm sensing consulting for popcorn, because this is going to be quite a show.
Okay, well, I'm sure these are things you've already thought through, Kareem, since we've just had a few seconds here with it. Watching a tail wheel on a differentially driven robot, it doesn't always do the same thing. It depends on where it was last left. So sometimes, for example, you might back up and it would swerve around to the left. Another time you might back up, it would swerve around to the right. And I actually spent a little bit of time trying to come up with an algorithm that would relate that to what the differential drive was doing. And I failed at that task. I was unable to model it.
That scares me.
Well, that's why I said this sounds hard.
But wait a second. Did I hear though that the swerve wheel, it's not a passive thing, it's driven?
It's not.
Isn't
It's driven.
it? It's driven.
Yeah,
So,
and it's not lagging. You know, typical casters sort of are off axis a little bit. And this one is dead center on axis, and it has a separate motor that's steering it at all times. So it can, you know, it needs to be a team member and not just to follow along.
Okay, one of the
Actively
things I
coordinated.
observed at the time was, suppose that the robot takes off and turns. The tail wheel doesn't immediately follow in behind the robot. It actually, you know, it curves in behind the robot to become straight. So if you're actually sending a command to do that, it's not enough just to know what I shouldn't say it's not enough. It wasn't enough for me to just know what the differential drive was doing in order to be able to predict how to drive that tail wheel.
But they're at least at the point where they have a mathematical model of how it goes. So
Well, they're way beyond me.
And they've implemented it as in the online like Desmos calculator, which is a graphing calculator that's available online. And so they have a model of it. And you know, the one thing that you can say is that if you have a differential pair and you know that you're asking it to turn to some angle, right? And you think of that tail wheel as being basically, it's a triangle, and based on where that's going to go next, the next frame, effectively, you can project where the swerve, has to go from here to there, right? So there's a vector associated with each of these movements. And the idea is that you just point that wheel along that vector and tell it to go that distance in the same amount of time. And it seems like it's almost that simple. But they haven't got to the point of, I mean, they're still building the robot, right? It doesn't exist in this form yet. But they're hopefully they'll get there by sort of next weekend. They'll have a roughly testable swerve wheel that they can, start actually getting practical, testing with.
I'm
Maybe
not
it
sure.
is that simple.
I'm not
Maybe
sure
it is.
this is as complex as you're thinking.
That's interesting.
Basically, you're saying you're making a turn, but based on what the differential drive is doing. So that the two differential wheels will be on a circle,
Exactly.
concentric circles. Your third wheel is also in a concentric circle that's just in the middle of those two the differential wheels.
Well, it's actually going to be further out. So if you think of the circle that connects the two differential wheels, the swerve wheel will typically be outside of that, and it'll have a larger radius. Like if you're doing an in-place turn.
No, it's not. No, it's got to be inside the two circles.
It doesn't have to be.
Yeah, it does.
Okay. Explain that.
Your two wheels are going to be making a circle. That front wheel
you're talking about,
has to be inside the other two. If it's outside, then it's not at all aligned with the circle that you're making.
Right.
Let's do the simple case of an in-place turn, right? So the differential pair is just rotating about the common center, right? In that circumstance, you could have wheel that's further outside of that radius, it's just got to go way faster as it goes around because it's got to cover the same angular distance
That's
over a
actually
much larger.
that's actually a simple case because that just means it has to be at 90 degrees because it's a tangent to the circle that the
At that point, it's a 90-degree, yes.
right. But
But
anything less than that, it becomes it's pretty much got to be inside the circle.
Kareem,
Mhm.
you mentioned earlier that there perhaps might be independent control of the two. I don't know what their
at different stages in the match.
yeah. I don't know what their sequence of getting this working is, but if you could have a person in charge of the tail wheel, steering and controlling its speed, and another person in charge of the differential, and just have them go out there and say, see if you can drive this around. What's required to make it work? Can you do this with two human brains, as the
Purely the humans making all the decisions, that seems like a mess. I mean,
Yeah.
in other words, you're gonna create forces where they're fighting against each other and sort of twisting up the robot. So
I agree with that, but think about those fire trucks where you got the driver in front and then you got the driver in back, and they each got their own steering wheel somehow.
I wasn't saying that
Sure,
they couldn't
yeah.
get into those situations, but rather that they might learn how not to get into that situation.
Right.
Which
sure.
might give an intuition about how the algorithms should behave.
Yeah. Kareem, building off of what Rudd said, it could be that your trailing wheel can only have two positions: 0, otherwise you're going straight, or you're turning and it's at 90 degrees.
No, that is not the plan.
But what I'm saying is, if either that, if that's where if the differential pair is doing the control, then that has to be, because it can you can either turn or you can go straight.
What about turning?
So
What about turning in an arc rather than
a
rotating?
gentle turn.
Okay, you go into a gentle turn, but in that case, the back wheel, when you're doing the turning, is going to have to follow those things. So it's going to be roughly at 90 degrees, isn't it?
No, it's only 90 degrees if you're rotating in place.
Well, maybe what I'm trying to say is two drivers, I think, is a disaster. I think you're gonna. The other thought I had was maybe you do everything based on what the tail wheel is doing. Let it be the controller, and then just drive the differential to match it.
Sometimes it is the front. Sometimes it will be the primary.
Well,
so
but I'm saying make it always the primary.
No, so there's it's a little bit complicated, but we're spanning two different objects that we're manipulating in the field, right? And there are going to be times when we have to focus on one end of the robot where the gripper is, and there are other times we're going to have to focus on the other end where the swerve is and the scoring element. And so there are going to be times where the differential pair, they care about their forwards and backwards, right? How far forward and backward they are along the axis of the robot. While the swerve is going to care more about the side to side movement because it's aiming the arm, right? So in other words, they're gonna be times when they have a different pair of constraints, but they have to all solve in the same kinematic model.
And that size of that T, is that fixed or not? Or is that tail wheel sort of moving in and out along that slider?
That tail wheel can drive itself in and out along that slider.
Oh, that complicates things.
Yes.
Now I think I'm not sure if everybody caught that part. I didn't.
And it's doing that throughout the match. It has to.
Okay.
There are constraints on the match that say it in order to pick up a new element, where the gripper is, it has to be really, really small because it has to be entirely inside a certain region, right? But the minute it has it, it needs to transfer it into the arm, and that needs to shoot out in order to score as fast as possible. Meanwhile, the differential pair is probably not going terribly far. It also has to come out of that area in order to score, but it doesn't need to travel as far as the swerve.
Okay, here's a thought. Why not change the mechanism so that you effectively have two differential pairs on both ends, right? And have some mechanical linkage that, makes the two a little bit more independent. I don't know if that's possible because mechanics is not my thing, but just so you have less constraints maybe, right? And more um
Yeah, we
you know
thought
so
about that. It could be another differential on the other end, and it's just pivoting on its center point. Um, they chose to go with the swerve, partly because it's a more interesting thing for them to fiddle with.
So,
And so
It's cooler.
so here's the question, because it strikes me that part of the problem is trying to figure out what angle does the swerve need to be for any given motion of the differential pair. So how do you keep those
right.
coordinated? And what I was just thinking was that, well, what happens? Well, two ways. Is there a way to sense? What kind of sensors could tell if you actually have the wrong orientation of the swerve wheel for what you're trying to do? Is there a way to sense that? And then I took that further and said, well, what happens if you blow off sensing it and you just do something like use an omni wheel there, so it doesn't really matter? So it's going to drive in whatever direction it wants to. If you're off a little bit, the omni wheels will let you make up the difference. Maybe just let it
I
be
think the
sloppy.
I think the grid might keep your omni wheels down. It's 1 inch pipe, right? 1 inch pipe grid on the floor.
Yeah, and we gotta cross that all the time. So
Yeah.
it was important to have a compliant
I
wheel.
still thinking here. Okay,
Mm.
It seems like if you're controlling the steer wheel, I still think that is the way. Otherwise, make your decisions on that, and then just let the differential match it. Okay.
Isn't it symmetric though, or not symmetric, but like if you've got it solved in one direction, you've got it solved in the other direction.
I don't know because
No.
the wheel can
Yeah.
go, the tail wheel
I
can go forward or backwards, right? So
Yeah.
you could actually solve the same
So
problem with two different solutions. I think
Another.
that's where it gets complicated. If you can imagine, do you know the spherical cow, right? If we
Mhm.
envision a spherical cow here, and I think this is kind of what Doug was describing, imagine that there is no differential steering, that those wheels just freewheel, and you're
Mhm.
driving the thing around from the tail wheel.
Tractor.
Well,
Yeah, like a tractor.
basically that's what you want the differential wheels to do. That is, if they were powered, you'd want them to be going the same they were if they're not powered.
I know, but it's exactly the same way as if you're doing it with differentials first.
Except that I think going
Now it
back,
also has that extension, so it just comes into it.
yeah,
I
I
know.
was ignoring that. That's not part of the spherical cow.
Yeah, but the other idea too is whatever way you want to control it, you can let the trailing wheel have certain bounds. Otherwise, you just basically let it become a caster. Otherwise, if it's going to do something weird that it's not going to be able to do it, it just cuts the power to it. I'm just opening ideas here. Some,
Mhm.
so
Yep.
so that way, if you're going to have the differential drive and it suddenly makes some really peculiar move, which the guy that was, instead of having the guy in the back trying to match it because he's not going to be fast enough. There's one guy's going to make the move, the other guy's going to be following it. What you can do is, but he might be able to, if you're going to do with two drivers, ideally you do it with one, is he could just push a button, which would kill the power to the trailer, which would allow it to turn into a caster. So you'd have a kind of a combination caster powered caster. Does that make sense?
Yeah, just thinking about the back forces on the motor on an unpowered motor, it would it would act like a brake. It's not freewheeling,
Yeah, but
and
well,
I don't see the need for it to be. I think that So when we
Well,
say that
what you would do there is you just put a diode in the direction that the thing is turning, you know, and then you, when the guy pushes the button, it also engages, which if he's going forward, it engages the backward diode, or if he's going backwards, it engages the frontward diode, so that it just shorts out the armature. So it just goes. I mean, you lose all your power there. I'm just saying that there might be some ideas here. None of this. I'm just throwing things on the wall.
sure.
Yeah,
Yep.
and but I still think it would probably be better to control it from. Otherwise, the driver is really driving the rear one, the steering one, and the differential. I think it would be easier to have it match whatever he's doing. Like, for example, if he's turning, you could, you're probably going to have you're going to have an encoder, a digital encoder on top telling you which direction you're going and how far you are, or you're going to have a potentiometer doing the same thing. So,
We have encoders on all of the motors.
Yeah. Okay. So you might be interested in, have you seen these new absolute encoders? These, they're, you can, let me go and I'll put a link in later. But
they have an index on them, right?
Well, no, it's a board and you have a magnet. And I guess when you turn the magnet, the board has, I guess, Hall effector sensors in it that can resolve the direction. You can resolve to exactly your location.
Right.
Okay. So
I'm not. Yeah. I think we're sort of good on that front. So
yeah,
with the encoders that we have, as long as the belts aren't slipping,
yeah.
we're gonna know which direction we're pointing, or how far we've traveled.
Okay. Well, I'll put the link in just so you can take a look at it.
No, that'd be helpful. Yeah.
Yeah.
Does this slider get locked at all, or is its position literally, is it wherever the wheel happens to move it?
That's a debate at the moment. So we're thinking about, there might be times when we want to put a brake on it. And there might, but right now, and that was the original plan, was you just deploy, right? And then it's like that for the rest of the match. But then when we were going through the math on the when we were building the model for it, it sort of became clear that we could just make that a variable, and we could just ask the third wheel to drive to that position relative to the other two. They were even thinking of not constraining it to being the center of that T, so it's just an in and out, but also being able to go at different angles to it, right? And I said, no, that's enough. We're complex enough at this point, and that would lead to all sorts of different tipping forces if you're, so at least it's going to always be an isosceles triangle that describes the relationship between the wheels. But so yeah, it can drive itself in and out.
So here's an idea, because it seems like part of the issue is the math between the differential rotation speed of that pair, and then the steering angle and speed of the swerve wheel.
Mm-hmm.
So the thought that came to my mind as we were talking was that, well, if you could, let's say that you could do some experiments and take data. So suppose you could move the swerve wheel to some distance, whatever, and you could lock it down in that position. And let's say that the swerve wheel was powerful enough to actually move the whole robot. So if you could unpower and unbrake the differential pair, then it seems like you could take the swerve wheel at different angles. You could just push the robot or pull it. And then you could come up with, by measuring the encoder ticks on the differential pair, you could come up with relationships of speed of the swerve wheel and the corresponding speeds of the differential pair.
Sure.
I think that's basically what I was suggesting. And Kareem's response was that if that's the case, then why can't you just work backwards from the differential to the tail wheel? Is that correct, Kareem? Did I miss something?
Yeah, it's the same relationship.
Well, but then that seems, so it seems to me that if that's the case, and if you accurately know the rotation of the swerve wheel and position, then it sounds like you got a mapping function. You can drive it either way. You can actively drive all three wheels either way. There'll be slop and error, but
that is the working theory. Yes.
okay.
Well, that's why my hypothesis or my concern was that the mapping from tail wheel to differential drive is fixed, but the mapping from differential drive to tail wheel can take several different routes because of which direction the tail wheel is pointing.
Oh, but
The tail wheel isn't pointing in any particular direction.
it doesn't
That's-
have a caster, right?
But it can rotate, correct?
It can rotate, yeah.
Okay,
And
so if it's aligned with the other two wheels
mhm,
and it drives forward, then the whole
Mhm.
robot goes forward.
yes.
And
that's
if
right.
it goes backwards, then the whole robot goes backwards. Now, if you rotate it 180 degrees, now when it goes backwards, the robot goes forward. And when it goes
Right.
forward, the rotate. Okay, so there's two different mappings to get the robot to go forward, depending on which way that's rotated.
I see what you're saying.
So if you start with the wheels, it's not so obvious how to get to a singular solution. But I think if you start with the tail wheel, there is just a singular solution going forward.
I don't think it is actually two different solutions. It's not like that sign flip is pretty much all it is. And I mean, if we constrained the swerve to only go 180 degrees, 90 to one side, 90 to the other side, you could still solve it, and you just might have to flip the direction that you're of travel. So I think it's going to be like go to the nearest angle of the two options that are valid solutions.
Seems like that if you're limiting the tail wheel to just plus and minus 90, that you can't do everything that the differential can do.
I was saying it's just a matter of switching the direction in which you're driving the tail wheel.
So, but the same thing would apply. I'm like Doug here. I'm just throwing stuff at the wall.
Sure,
Seems
sure.
like, the same thing would apply if you were, let's say, driving in an arc. So the tail wheel is turned, let's say, at 20 degrees, and the robot's rotating through an arc. Now, if you stop, there's two different ways you could go back along that arc. One way is you could just reverse the tail wheel.
Yep.
And that would drag you back. The other one is you could turn the tail wheel around 180 degrees and drive forward.
Right.
Both
And
of those-
I'm saying we just optimize to turn to the angle that is closest to the last angle. That is conservative, right?
The point I was thinking, which maybe I wasn't, was why my gut tells me that mapping from the differential to the tail wheel is not the same as mapping from the tail wheel to the differential.
Well, we'll find that out, I guess. Yeah.
I think David's idea though of leaving, have them drive it with one of them powered up, either one or the other, and see what's going, is a good one, and that will tell you real quick probably some things that we can't fathom right now with such short notice.
Yeah.
So but I still think you're going to find that if you're going to do it, you're going to drive the tail wheel. I still think that's going to be the way to go.
But we're not short of opinions, even for topics we know nothing about.
That's true.
Can I show something here?
Sure.
Sure.
Rudd, I was looking at your website. You had some good tips on steering the rover type, Mars rover type platforms.
Thank you. Okay. This is basically the problem, I think. That doesn't look too clear to me on the screen, but maybe you're seeing it better than I am. You've got the vertical line here is your differential drive.
Mm-hmm.
When those wheels are making a circle.
Yep.
Okay, 2 circles.
Mm-hmm.
Your third wheel out front is going to follow this circle.
Okay.
Even if you move this if you move your swerve inside here, then it's just going to be making the circle as I commented on before, which is inside these other circles.
Mm-hmm.
So it seems to me this is relatively straightforward trigonometry.
Exactly.
Of, you know, we know on differential drive how to calculate these circles based on the speed and their and the wheel diameters. And so then we just need to be able to use the trigonometry to determine what the outer circle is supposed to be in this case, and what the tangent to that circle is at that point.
That's right.
Kareem, do you have a sensor that returns the distance from the tail wheel to the center of the differential? That's what would.
Yes, we're actually using a laser distance sensor.
But because that's the value you'd need to do that, right?
That's the one to confirm that it's where you expect it to be. Yes. Let's not get started on a PID discussion at this point. But yes, we have to correct that. That is an error bar. We have to correct for when the swerve is further away than we're actually asking it to be. There's no doubt about it, and that's going to make it a little bit more complicated.
Okay, if you always think of the swerve wheel as whether leading or trailing, is if you're thinking that it's always going to be either behind, in front of the robot as the robot's traveling straight, or it's going to be to one side or another as the robot turns. Maybe that's a sufficient constraint. With a real castering tail wheel, the wheel, if you back up, actually swings around in underneath the robot, and which way it comes out, is a matter of chance, depending on.
This is definitely not a passive swerve. I mean, a caster. Yeah.
But
so that's where I see the problem occurring, is where you're moving into a situation you're not going to caster, but if you're backing up, I need to think about it.
Well, then I've accomplished my initial goal of getting y'all to all think about it. The important part is to communicate this to the team, and so if anybody, you can just email me directly or whatever. If anybody has some time over the coming weeks, we'd be happy to put this in front of you. And maybe I should invite some of the team members to come to next Tuesday's to elaborate a little bit further.
Well, is this useful, what we have done today?
Absolutely. We haven't gotten beyond the stuff that I've been thinking about, but again, it's about how to teach the team. I'm struggling myself, right? In that it is a complex subject, and I'm not always explaining the gotchas maybe as well as I should be. So this is definitely helping me think about how to communicate the problems a little bit better.
Can I ask one more question so I don't dwell on it all night and not lose sleep because of it?
Sure.
So, so it seems that to me that there's a difference, a big difference between a passive caster and this active swerve wheel. And that is that a passive caster, at least the encoders on the differential drive, you can probably rely on them. Maybe they'll slip, but it seems like at least the caster's not, if it's a good caster, it's not going to be fighting them as much as if you have an active swerve wheel. It seems that to me, if you get that trig wrong, and if the swerve wheel isn't, if the distance is wrong, if the angle is wrong, if the speeds are wrong, that the chance of wheel slip happening to where the encoder counts become off for one or more wheels, it seems like the chance for encoder counts to be off is higher because of this. So my question is, are they relying on encoders for like positioning?
Ah, that's an entirely different issue. Um, so they are actually working on a optical flow sensor to be an independent travel. Yeah, basically, the ones um, that we've been talking about from Pimoroni,
Yeah.
and they're trying to get those integrated into the robot so they have an independent source of travel that should not be troubled with wheel slip.
Okay.
But for right now, these wheels are super grippy. There's almost no chance of wheel slip. There is probably a greater chance that the belts slip on the drive belt slip. Although actually they're still on chain at the moment, so yeah, I'm not sure exactly how that's going to work. Um, I mean, there's going to be errors. This particular this particular game this year does not rely on uh, localization as much as it has in the past. So so there are plenty of teams that are getting by without worrying about odometry this year, especially since that barrier just makes it much more difficult. Most teams are using Omni wheels as their odometry. You know, freewheeling Omnis as their
Tracker.
odometry. Yeah.
Thank you.
hmm
Well, it's an interesting problem, Kareem.
Yeah, I posted a link in the chat that is their Desmos calculator.
Yeah.
I can't actually tell you how to use it. It has sliders on it, so you could find the. I don't know if it's well enough documented at this stage. I haven't reviewed this latest version of it, um, but it is up there. And basically, the dotted triangle, the orange triangle, would be the future position that you're asking it to be, and the green is the current position. And it basically shows the you know the connection. I hope it still shows the vectors of the connecting points between the different positions, but they're assuming that they're basically steering off of those vectors at this point. And it seems like a very straightforward trigonometry for that solution. And again, there are practical considerations like uh, uh, encoder reliability and things like that. Um, but the distance between the front and back is going to be a distance sensor, laser distance sensor.
Sounds like they got every sensor except they got to be forgetting one. What else do we have to put in
there? they got IMUs. There's no uh, what were we talking about earlier today?
LiDAR.
There's no LiDAR allowed. Yeah. Unfortunately, but they got cameras, so um, they're doing they're building their own TensorFlow pipeline right now. Man, we'll see how that goes. There's an object recognition problem at the very beginning of the match.
Kareem, are they going to be able to use LiDAR light? Will that be a legal part for them?
No, there's a single laser allowed on the robot, and that is a very specific model that Rev produces. It's a distance sensor. It's got out to 2 meters, and that's it. That's all they're allowed. Otherwise, directional optical sensors are let's put it this way. They're not allowed to use any focused light, right? So they can't, except for this exception for this one sensor.
Yeah, but how would, since a LiDAR light is, oh, excuse me, I said LiDAR light, I didn't mean that. Oak D light, excuse me. Will they,
Oh, we don't have a ruling on whether that would be legal. It has to have a UVC driver on it, but it would have to. Does I need to even check. I know on the Intel RealSense cameras, there is there's an option to turn on and turn off um, the laser grid, right? We would have to turn that off for it to be legal. So
I don't think there is a laser grid. There's no laser in it.
there might not be a laser
Yeah,
grid
it's just 3
in
cameras.
OD.
Yeah, it's just 3 cameras.
Yeah, okay. In that case, it's a possibility because I think it's got a UVC driver.
Hey, this wheelie thing is fun.
Yeah. Does it seem right to you?
I move the sliders and it all moves around, and I say, yeah, that looks right.
Yeah, and it's consistent looking, right? So that is so they worked out the formulas, and hopefully they do have a way of controlling this thing.
If anybody else is logged in, play with n equals 0. That's a lot of fun.
Oh my goodness, my mind is frying. Alrighty.
Well, thank you guys. Appreciate it. So next steps, I think, is I'll see if some of them can at least maybe explain or demo the calculator, and give at least give an update on where they are. Right now, it's not even constructed. Right, they're still like
Modeling.
we're bogged down in CNC machining of the parts for this.
Hey, Kareem, are you still happy with the CNC machine you bought?
Yeah, it's got its quirks. We fairly regularly run into situations where when we start up a new program, it jams and and it loses steps, so we have to recalibrate it. It hasn't ever done that while it's cutting, or at least not for a long time. So there are some quality issues, but we're able to, and we have to go very slowly. So when we're machining aluminum, we're now at the stage where we're using like a 1/8 inch flat end mill, and we're only cutting 0.15 millimeters per layer.
Oh, what's the RPM there?
10,000. The spindle is 10,000.
And you're cutting 1.15.
0.15 millimeter step downs. It can cut much deeper, but this is like the set and forget. It's a very light. The forces are much lower, and once it's got the path figured out, it's also going faster. So we used to have this problem where we would cut deeper, but we'd have to go slower, and as a result, the aluminum built up enough heat because we don't have any lubricant flowing over it, and so it would actually sort of spurl up and get gummy, and you get really bad cuts.
Aluminum does that. It's a real magic. It's a real magic to find just the right.
Yeah. So this is an unusual feed and speed combination. It's just like skimming a little bit at a time, so it takes a while to cut a big part. It's still faster than 3D printing, and much stronger parts. We're about to try. We still haven't gotten around to cutting carbon fiber yet, but we're planning to do that this season. So
That's nasty.
That's nasty. I know.
Yeah.
It's very, very nasty. We've got a vacuum on it, but even there, you still have to take a lot of precautions.
So does it leave a nice, beautiful knurled surface?
At this point, it's clean.
Cool.
We're going much faster, so we're not building up the heat. We're just taking these very light cuts. and so that you can't build up a lot of heat in one location. So it's looking okay.
Well, that would drive you crazy if you were machining it by hand, but with a CNC,
CNC, you can walk away from it
you'll
once
get
you.
a sandwich.
Yep, exactly.
Cool. I think we have, we've been dropping people, but we have Ray still. Ray's been waiting. What you got, Ray?
Oh, I was just kind of curious. My laptop's getting a little older, and it's I think, I don't know, probably a 1 gigahertz i5. I think screen resolution is like 1366 by 768, so that kind of tells you how old it is. Kind of wondered what other people are using, and if you're still using antivirus software or like internet security software.
Are you thinking Windows or?
Yeah, Windows.
Well, I on the security software, I have a recommendation. It's WebRoot.
You like WebRoot, yeah.
I like WebRoot. And if you look around, often you can find a deal on, don't go to their website and just buy it. It's better to see if you can find a package. I used to get it from Fry's, yeah.
Yeah,
but,
me too.
But
Right.
yeah, you'd buy it for almost nothing. But I don't know. I got a 2-year license. The last one, I'm still working on it.
Yeah.
So that would be my suggestion for security software.
Yep.
You know.
Yeah, I actually tried Avast, and you know, it seemed like for the features that it was offering, it was about the same price as you know, some of the others. And then you know, I went to install it, and come to find out, all the you know, like you know, VPN, and you know, if you want to, you know, clean up a disk, or you know, kind of rearrange, you know, defragment a disk or something like that. All those things are extra, and there's a subscription for it.
Yeah, no subscriptions here.
I know. I was like, what?
So Ray,
I just went to the WebRoot page and it's offering 50% off.
Yeah.
Yeah, but I take 100% off. I like the school of thought I picked up from Mr. Edwards from Microsoft, which is that Microsoft has really come around and done it from the days of XP. They've done a tremendous job these days.
Yeah,
So they're much better. They're much better, but WebRoot's better.
I don't. Okay,
I don't know that I've seen any data to indicate that or that anything is better than Microsoft's Defender, the built-in integrated Defender. It used to not be that case, but it's just rock solid. It catches more than anything else that we try at my work, and so we've stopped bundling any extra on the units that on the machines that we ship to our our workers.
Yeah. Okay. Yes.
And your machines will run better without the third-party crap getting in the way.
Yeah.
I'm sure of that.
Mm-hmm.
And I can sure I've run my boxes and all the ones in my family without anything but the Microsoft for the last like 4 or 5 years. No problem.
Really?
No problem.
Ever since Windows 10, I haven't
clean.
seen anything better. Yeah.
Okay.
Ray, what version of Windows are you currently running?
10. So yeah, it seems like you've got to have additional hardware to support encryption for Windows 11, and it's more expensive, and there's not a lot of boxes that do that, and so I don't know. I'll probably stick with 10 for a while. Yeah, this is an i5. Like I said, I think it's, I don't know, around a gigahertz or so. It's not the fastest i5 that's out there. Your laptop, Carl, is it an i7 or an i9? It's pretty
neat.
Yeah.
Oh, so okay. So what I got it's an i7. I didn't spend the money for the i9, but it's an i7. I did spend money for a graphics card, so it's got an NVIDIA graphics card in the laptop.
Okay.
Not that I've really used it like I thought that I would. But either for video editing or for Donkey Car, but I got it anyhow. Every now and then I pull up and look, and it does pick up some of the tasks, but you can change power plans, right? So I run because I want the fan noise to be relatively quiet. I run it in like overnight mode most of the time, which then doesn't use the NVIDIA. So I don't use half the CPU power. I probably overbought on that. But the i7 is definitely nice, and I like the 1080p displays, and I figured SSD and a lot of RAM.
Yeah.
So I put 48 gig of RAM in here, and I typically run just with what I do because I mix personal and work all together. I usually have like 30 gig of it used of RAM.
Wow.
At any given time, and then I reboot once a week, and stuff really doesn't crash that much.
You can
Yeah, I agree with the extra RAM. I know
I
I'm
would do
running
that over CPU, but I'd go for the i7 because I think that's going to get you stuff that beyond the i5 that you'll notice.
Yeah.
And I'm using 24 gig of RAM right now, so I got 3 displays. I got probably 3 dozen browser tabs open.
And you can actually get that much RAM in a laptop?
I read somewhere that the beta version of Windows 11 was crashing because they were embedding advertising in the operating system.
Wouldn't doubt it. But I also, Ray, I put money in this one because I wanted it to last. So this is a Lenovo X1 Carbon Extreme. So
Those are nice.
It's a little high. It's a little on the high end, but you can get specs, and they did that because it's thin and it's light. But I still got to tell you, it's got a 4K display, even though I use it in 1080p. So the extra display and the graphics, they just suck the battery down faster. So I would say you'll have a nice step up if you go to a 1080p display. And I like the 15.6 instead of get a microscope to read your display.
Yeah.
So a nice big display and an i7, a lot of RAM, SSD. And I'll shill for Lenovo all day long because from the brands I've looked at, they have fantastic support, drivers, maintenance. They've kept up the legacy from IBM pretty well, as far as I can tell.
Yeah.
Wasn't that the last one you had too, Carl? The one you had before this one wasn't that one too?
Yeah.
I remember you used to bring it to the.
Yeah, I had that was and Lenovo has an outlet center, so it was a T520 that I got in 2012, and that lasted until like a year and a half ago.
Oh, okay.
Well, Carl, for such light attendance, this has been the longest running meeting I've ever attended. So I just realized it's close to 11, so I'm bailing.
Time flies when you're having fun, but good to talk to you.
Yes.
We'll see how.
See you.
So Ray, Lenovo has an outlet center where you can get refurbed and others, and I found they do pretty good as well.
Just online, not like a local store or anything.
Yeah, it's online.
Yeah.
Like I had a refurb Dell once, and it was just mechanical crap. It just fell apart.
Yeah.
But
I would second the recommendation to stuff it full of RAM.
Yeah.
We run into this all the time at work where we're helping people set up machines in their office, and they have this idea that, well, I'm going to buy this and then later I'll expand it. And I tell them, I've been doing this for 30 years. You will not expand it later. Do it now. For one thing, you won't be able to find those memory cards when you decide to expand it.
Yeah, they'll be, what do they do? 4x each generation, and that one will fall off. And
stuff it full of RAM.
Yeah.
And RAM is way more important than processor speed.
I agree, and there ain't no substitute for physical memory.
RAM and SSD. Don't you get a spinning disk? I'm not talking.
I agree with that too. Yeah.
Yeah, I know the SSDs are a lot faster. I think they're still saying that mechanical disks have better reliability than SSDs, though.
SSDs sort of crap themselves over time.
Yeah.
But Carl, just to add on to one more accolade, my son, who is a merchant marine, was complaining because he carries his laptop around with him. And what you want is something that's small when you're carrying it, traveling 2,000 miles, but then when you're actually sitting down to use it, you want something. So after much complaining and going back and forth, he bought this a couple of years ago, real nice Levino with this really good, crisp, high resolution screen that he can do his gaming and watch his movies and all the stuff he does when he's at sea. And he's been real happy with it. And it's a lightweight, it's thin, it's fast. And as I say, once you get there, you want a big computer. It's like having a travel trailer.
Yeah.
The
That's
other,
right.
if you go Lenovo, the one thing I'd say, we could talk offline, but I think they have different series. So like they have the lower end economy ones for students, and they have like performance ones for gamers, and then they have the T series for business people and workstations.
Yeah.
And I just comparing what I've seen on like the T520 I had to the Yoga that I got my mom. No, really, I think I don't know what it is. I've never looked at the architecture, but I could swear that there's some kind of difference where same specs on a T series versus the more consumer focused, home focused, student focused. I think there's a difference on speed, on performance.
Mhm.
There is, yeah. I was just showing you both
Oh,
a T series and a student grade laptop, and there it's not just the processor. There's uh, and just the total build quality. It's
right.
just, it's worth it. It's worth spending the extra bucks
It really is.
because they really last.
Mhm.
The hinges. I
But
mean, I have.
this one has been hit by robots multiple times because a son of mine was like sitting there programming on the field and then testing right there and then driving the robot into it.
Occupational hazard.
Yeah.
It was a Timex. It took a licking. And kept on
Yeah,
ticking.
attacked by robots.
But they have, at least on some of them, they have these crazy design features. So I'd taken these apart so many times. This is my old T530, right?
Yeah.
And I had always wondered, what's that symbol? What is this thing with the keyboard and do you guys know what that is?
Isn't that a Kensington lock?
Nope.
No, what is it?
Try again.
It's
All right. And I
keyboard?
found this out the hard way. I found this out because what they actually do is on the keyboard in there, if you take it out, you can see it, but they have a guttering system. So if you spill water on here, that
You can
gutter
drain it.
funnels water through that hole and it misses the motherboard. And I can tell you that because I spilled a full, like a 16-ounce glass of water on a Lenovo T60, and I thought, this is terrible. It's never going to work again. The water is draining out from the bottom of it. And 2 days later, it was working fine. It worked fine ever since.
A testimonial.
When I worked at DSC Communications Corporation, I had a friend named Charlene Lynn, and she was, always had a, bottle of Coke on her desktop, and she'd like finish one a day. And one day I see her, and she's coming out of the ladies' room with her keyboard, and her keyboard is all wet. Spilled the Coke into the keyboard and decided to take it in and rinse it under the faucet. So it didn't work after that.
But it was amazing. I mean, show me some other random office laptop that has that kind of thought put into the mechanical.
Yeah.
I mean,
that's pretty good.
And it worked. I mean, it wasn't just a concept; it actually worked.
Huh.
But it's not in every one of theirs. So, like my daughter's college, we got our X1 Carbon second generation for college. And then it wasn't until like the sophomore year that a glass of wine showed that one did not have the drain holes.
Oh, yep.
Well, that's the wrong one for a college student.
Yeah, that was clearly messed up. I don't know what we were thinking, but
Kareem, I was just going to add, when you guys, I'm sure you've thought all this through, but when you guys start machining your carbon fiber, there's a lot of hazards associated with that. all the way from the small end of, if you ever get carbon fiber splinters, you know, your body won't reject them. They just fester and they're awful. And then if you got the fine dust and you're breathing it, that can be very, very hazardous. So it's
Yep.
nasty stuff. I've done
Yeah.
some machining of it, and I prefer not to.
Yep. We do have a full, really heavy duty vacuum that ejects it outside. And we've got, you know, the masks and the breathers and all that kind of stuff. So, yeah, we're gonna take a shot at it, and we probably will end up deciding like you did. It's just not worth it. But
Well, it's really cool stuff to work with. It's so light,
Sure.
so strong. You can
So
super glue it
stiff.
together. It becomes super strong. I mean, there's a lot of things to recommend it, but machining it, I don't have a big vacuum cleaner. I just found it hard to do, hard to live with.
Do you have a neighbor that you don't like? You can exhaust it on that side.
I think Kareem has some space around him out there.
I have a little bit of space, yeah.
Well, you know, you don't want to pollute your own space, you know. Yeah. Okay. Well, thanks for the recommendations. I was looking at, you know, laptops at Micro Center, and it's kind of like, oh God, you know, price ranges are all over the place.
It's a good time of year.
Yep.
Ho, ho, ho.
If you're gonna get it,
Gentlemen, are we done?
Seems like we're there, guys.
Yep.
Good to
Have
talk
a
to you
good
as
night.
always. Have a good night.
Thanks again.
See y'all soon.
Excuse me.
Bye.